Picture this. It's late, the lights are low, and the sky outside your window looks like a black ocean you could fall into. On the table between us, there's a napkin with a messy doodle, a circle for the sun, a tiny dot for Earth, and a bold arrow sweeping inward like a dare. The arrow has a name scrawled above it, 3IATLA. It sounds like a code word someone whispers in a movie right before the music tightens. Now, before your heartbeat tries sprinting, breathe. Tonight isn't about panic. It's a bedtime story with the volume turned down one. What if, tucked under a warm blanket? What if this interstellar visitor, a traveler from far beyond our neighborhood, wasn't just passing through? What if the line on our napkin bends a little closer than anyone planned? Close enough to make even the calm people clear their throats? We're not here to sell doomsday. We're here to keep you company while we walk the edges of a question humans have asked since we first looked up and saw anything move. If something big and fast came our way, what would actually happen? Who notices first? Who calls whom? What breaks? What holds? And what quietly surprises us by not breaking at all? Pull your chair in. We'll keep the tone friendly, the feet on the floor, and the monsters labeled clearly. Facts, maybes, and pure imagination. The arrow isn't destiny. It's just a story. Let's see where it points. The first thing that would happen isn't an explosion or a headline. It's a whisper in the data. Somewhere in the nightly stream of sky pictures, a dim dot would slide ever so slightly against the wallpaper of stars. A survey telescope would notice, then another, and the world's clearinghouse for moving things in space would start stitching those dots into a path. At first, it would look like any other newcomer, but the math behind the scenes, really just fancy curve, fitting with a lot of humility, would start murmuring. This one isn't looping around the sun like a local. It's on a hyperbolic path, the celestial word for passing through. And then the part nobody likes to say out loud, that path might intersect ours. From there, the tone in the room changes. Astronomers are not thrill seekers. They are patient gardeners of pixels. So when they say, we need more nights, it isn't suspense, it's safety. Every fresh measurement shrinks the fog around a prediction. Early is everything, as one planetary defense engineer likes to say. The first 24 to 72 hours are like meeting someone in a crowded station. You think you know their direction, but one wrong step and you've lost them. Add a week of tracking, and the hazy arrow becomes a dotted line with confidence bounds. Add 2 weeks, and the dotted line turns into a lane. Here's where our story tilts toward your kitchen table. If 3I Atlas, this interstellar traveler with more speed than our usual comets, were headed even slightly toward Earth, the early calls would go out fast and quietly. The Minor Planet Center would post updated solutions. NASA's Planetary Defense Coordination Office would compare independent fits. The European and Japanese teams would run their own. No red banners yet. Just careful, boring, relentless checking. Fact: the first numbers are never the last numbers. Hypothesis: if the numbers still point uncomfortably close after a week, they tend to keep pointing that way. Speculation: a sleepless coffee machine becomes the most important instrument at several observatories. Speed matters because it sets the mood. Near-Earth asteroids mosey along at highway tempos by cosmic standards. Long-period comets are sprinters. Interstellar visitors are the marathoners who never slow down. The faster something arrives, the less time you have to think, and the more energy it would carry if it hit. You don't need equations for that. Just imagine catching a baseball lob versus a fastball. Same ball, very different conversation with your hand. Now, if the path of 3IATLA is tightened toward a bullseye, there are 3 kinds of truth we would keep straight as we talk to each other. Fact: what the telescopes measured. Hypothesis: what our models say should happen next. Speculation: the what-ifs that help us prepare even when the models disagree. We do this separation not to be coy, but because mixing them is how panic grows. It's the difference between a weather report, a forecast, and you staring at the clouds trying to decide whether to bring an umbrella. So what would actually happen, step by step, in a calm, daylight kind of way? First, precision. Radar would join the party if the object's geometry allowed it, pinging the visitor with radio waves to pin down its speed and distance with ruler-sharp accuracy. Infrared telescopes would measure heat to estimate size and surface properties. Since a dark, snow-like surface can look tiny in visible light, while a warm, bare rock looks bigger than it is, we'd want to know if we're dealing with something the size of a sports arena or a small mountain. Those two things write different endings. Second, messaging. Risk scales exist precisely, so we don't need a PhD to understand the odds. One common dial is the Torino scale. 0 means no threat. 10 means global catastrophe. Most things briefly flirt with a 1 and then drop to 0 as the orbit firms up. If our hypothetical 3-eye atlas kept its numbers stubbornly above 1, you would start hearing phrases like a non-zero probability on date, and you would see professional shoulders tighten. Extraordinary claims require extraordinary evidence. Carl Sagan warned, and that's why no serious team will declare danger on day 1. But they will tell you, plainly, when the needle moves. Third, playbooks. The moment the path looked wrong, mission designers would open drawers labeled kinetic impactor, gravity tractor, and if the clock is mean nuclear standoff. Those names sound like comic book gadgets, but they're just different ways of giving a cosmic nudge. A kinetic impactor is the simplest. Hit the object with a fast, heavy spacecraft and let the recoil shift its track by a hair. A hair today becomes a highway width miss months from now. A gravity tractor is quieter. Park a hefty spacecraft near the object and let neutral gravity tug it off course over time, like a polite dance partner guiding a turn. Nuclear standoff is last ditch. Detonate a device near, not on, the object to vaporize a skin of material on one side. The expanding vapor pushes the rest the other way. No mushroom clouds, no Hollywood drama, just physics, deliberately applied. Notice the refrain, time. A millimeter per second of change, months early, beats a meter per second of change, days late. If 3I at LAS were an interstellar sprinter, the warning would likely be short, measured in months. That's enough to move a 100 to 300 meter body with kinetic nudges. It's tight for kilometer-class objects, where nuclear options step onto the stage and lawyers start flipping through treaties with white knuckles. But tight isn't impossible. The difference between the two often lives in whether governments can make decisions at the speed of science. Okay, but let's honor the picture in your head, the big one. If the worst held, what would a hit actually look like? The answer starts with 2 doors, airburst or crater. Loosely bound, icy objects, think of a snow and dust truffle, tend to break apart high in the atmosphere. The result is a brilliant flash, a wave of heat, then a pressure pulse that can knock out windows and knock down buildings across dozens of miles. That's terrible nearby, survivable farther out, and essentially a regional disaster. Think of a hurricane's footprint, but with different physics. If the object is larger and tougher, or simply unlucky in how it meets the air, it reaches the ground. Crater size scales up fast. Something a few hundred meters across could carve a bowl the size of a city. Something a couple of kilometers across moves into Mach-changing territory. Land impacts throw rock dust high into the stratosphere, where rain can't scrub it out quickly. That fine dust acts like a global dimmer switch for sunlight. Ocean impacts trade dust for water and waves. A deep-sea strike can launch tsunamis that cross basins and arrive half a world away hours later. Neither option is good. Each is different. Here's the part people often miss. The first minutes are loud, but the longer story is quiet. It's sunlight through the filter of dust. its growing seasons shortened by chill and shade, its supply chains trying to push food and fuel across damaged roads, while power grids hum under heavier loads. It's also ingenuity greenhouses, indoor farms, heat pumps, seed banks, and the thousand scrappy tricks humans deploy when the stage lights go out. Fact: Earth has recovered from far worse given time. Hypothesis: as a species, we tend to overestimate chaos and underestimate adaptation. Speculation: if you give us one winter to plan for, we'll invent a dozen ways to make it livable. Let's circle back to the beginning of the fear, because it's honest. The idea that something ancient and alien-born could be aimed at us feels personal. 31ATLAS is exotic by passport interstellar, but ordinary by parts. Ice, dust, rock, maybe organic molecules, baked by radiation for eons. The universe is allowed to be both strange and natural, as one astronomer likes to shrug. That matters, because the moment you imagine intention, the sci-fi version where the path looks chosen, you slide from physics into story time. Curious? Fine. Useful? Only if it pushes us to ask better questions about what we actually do, not why some invisible someone would do it. So, what would we actually do in a heartbeat-by-heartbeat rhythm? We'd listen. Sky surveys in Hawaii, Chile, South Africa, Arizona, the Canary Islands, everywhere would feed the same machine. Observe, confirm, predict, repeat. The new giants, the Rubin Observatory and the upcoming infrared Sentry in space, would add deep, frequent sweeps and the ability to see dark objects glowing with their own warmth. That's handy for things sneaking in from the sun's direction, otherwise our blind spot. We'd talk. The international networks that already exist for this exact problem would spin up. No country owns the sky. Everyone shares the consequences. The paperwork is dry, the teams are small, and that's precisely why they work. They were built by people who wanted facts to travel faster than rumors. You'd see joint statements, you'd see careful language, you'd see uncertainty ranges explained in plain English. We'd decide. If the clock said months, you'd see proposals go from slides to launch pads faster than bureaucracies normally move. A kinetic impactor can ride a commercial rocket. A small fleet can go in waves. Each hit is a little tap. Add enough taps early enough, and the missed distance grows from frightening to comfortable. Deflection is a game of inches played millions of kilometers away. One mission designer joked. It's funny because it's true. And if the clock said weeks, that's where honesty matters most. We can't promise miracles. We can promise competence. If nuclear standoff became the only lane, the argument wouldn't be about taste. It would be about geometry and timing and the cleanest legal path through old treaties written for a different era. We would also do something beautifully boring and heroic: civil defense. Evacuation modeling for coasts if tsunamis were in play. Grid hardening. Surge purchases of diesel for generators and fertilizer for greenhouses. Pre-positioned food, medicine, and water. We do these things for hurricanes and wildfires. We do them for skyfire too. Meanwhile, scientists would squeeze every last lesson out of the visitor, because that's how we turn fear into tools. Spectra tell us chemistry. Light curves whisper shape and spin. The way a tail grows or doesn't grow as it warms tells us whether the surface is crusted or fresh. These aren't trivia. They change which deflection method works best and how much push you get per kilogram of spacecraft. Know your rock sounds silly until it isn't. If you're hearing a theme measure, communicate. Act you're hearing the quiet truth that lives under the loud hypotheticals. We have a plan. It can be better. It is getting better. The first interstellar visitor we met, Oumuamua, surprised us and slipped away. The second, 2I Borisov, behaved like a classic comet. The third, 3I ATLAS, is a prompt to ask grown-up questions with steady hands. Not, are we doomed? But are we ready? And readiness isn't just rockets. It's perspective. It's remembering that sensational headlines love the word asteroid the way junk food loves salt. It's noticing the difference between a 1 in a million path and a 1 in a million outcome. It's keeping two ideas in your head at once. The probability of impact is tiny. The consequences, if it happened, are large. That pair doesn't call for fear. It calls for homework. So, if 3-Eye Atlas bent toward us, the night would not end with a cinematic boom. It would begin with human beings doing what we've always done when the dark pressed in. We'd light a candle, compare notes, and get to work. We'd draw backup plans for our backup plans. We'd treat rumor like a spark near dry grass. We'd keep a sense of humor because it helps, and a sense of duty because it matters. And somewhere, in a control room with the lights turned low, a small team would watch a live feed from a spacecraft, barreling toward a speck, and say something simple like, "Guidance is good." If the speck budged, even a little, the math would carry that nudge forward like a gift. The arrow on our napkin would miss the dot by a safe margin. The story would end with a sigh you could hear around the world. And if the speck didn't budge, then we'd move to the next best thing humans do: protect each other. The same ingenuity that builds probes, builds shelters, lights fields with LEDs, grows lettuce in shipping containers, and pipes clean water where it's needed most. We don't have a single superpower. We have 1,000 small ones. There's comfort in that, I think. 3-Eye Atlas isn't a morality play or a prophecy. It's a visitor that lets us rehearse being our best selves without the heat of a crisis. Hope is not a plan, an old emergency manager line goes. True, but a plan without hope is dry tinder waiting for a spark. We carry both. We should. And tonight, as you drift, the arrow on the napkin is just lines and ink. The dot for Earth is still a dot. The sky is vast and mostly quiet, and the people who watch it are very, very good at their jobs. If the day ever comes when a visitor draws too near, they'll tell us, and together we'll do the stubborn, ordinary work of bending its story away from ours. Imagine 3 clocks ticking in the same room. One is the physics clock. It doesn't care about politics or feelings. It just counts down to where an object will be when gravity's finished talking. The second is the launch clock, how fast we can get a rocket off the pad with something useful at the top. The third is the human clock, the time it takes for us to understand the risk, agree on a plan, and actually do it. If 3-Eye Atlas bent its path toward Earth, the story that follows would be written by which clock wins. Start with the kind of timeline that makes professionals sweat, but doesn't send them under the desk. Months, not days. The first thing you hear is that the risk corridor, the skinny ribbon of space where the object could pass once you account for measurement fuzz, still crosses our planet. Fact, tiny pushes, applied early enough, can make a big miss later. Hypothesis, a handful of fast, uncrewed spacecraft kinetic impactors could tap 3-Eye Atlas just hard enough, in just the right direction, to slide that ribbon off Earth. Speculation, it won't look like a hero shot. It'll look like a convoy of unglamorous, extremely dependable space buses doing their job. A kinetic impactor is exactly what it sounds like. A battering ram with a brain. We've already done a rehearsal. In 2022, NASA drove a fridge-sized craft into a small asteroid moon and measurably changed its motion. Engineers loved the boring part most. The numbers matched the models. Bonus points. The spray of debris kicked out by the hit acted like extra exhaust, giving the target more of a shove than the spacecraft's mass alone could provide. Rubble is your friend, one mission lead quipped. The point isn't one cinematic punch. It's a sequence of precise nudges that add up. Designing that kind of mission on a clock is part Lego set, part sprint. You raid the shelves for flight-proven cameras, guidance computers, and star trackers. Bolt them to a dense slug of metal, and wrap the whole thing in software we already trust to dock cargo ships to space stations. Private launch capacity helps. It's no longer a miracle to get a ride on short notice. You're not aiming dead center. You're aiming for the angle that matters most, like pushing a revolving door where your hand does the most good. But all of that depends on what we learn in the first weeks, because every small body has a personality. A fluffy snowball reacts one way, a compact ice rock boulder another. A slow tumbler takes a nudge differently than a fast spinner. We estimate size from how bright it looks and how that brightness changes as it turns. We estimate temperature with infrared light. Heat tells the truth when color lies. If we can bounce radar off it, we get ruler marks for distance and speed that sharpen everything. Know your rock and you'll know your move, says a small body dynamicist who has spent 20 years squeezing secrets out of flickering light curves. If the calendar turns cruel weeks instead of months, the conversation shifts to tools you keep in a glass case. You'll hear nuclear standoff, which is less dramatic than it sounds. No one's talking about cracking the object open or lighting the sky like a movie. The idea is to release a burst of energy at a safe distance so a thin layer of surface material vaporizes. That vapor rushes off like rocket exhaust and nudges the rest away. It's a last-ditch option, not because the physics is suspect, but because the politics and precision are hard. Treaties written for a different era don't map neatly to "let's not get hit by a comet." As one space law specialist puts it, the rules weren't designed for this, but they weren't designed to forbid survival either. If, on the other hand, the clock smiles years, not months, the whole plan gets gentle. You can park a heavy spacecraft near the object and let mutual gravity do slow, exquisite work, tugging the trajectory by millimeters per second that become thousands of kilometers months later. Add a scout or two, a small craft, to map the surface, sniff any gases, test the texture, and you're playing chess instead of dodgeball. Early is mercy, says a planetary defense analyst. Mercy for budgets, nerves, and neighborhoods. While the engineers sketch trajectories, the communicators do their own kind of navigation. Risk needs translation. That's why simple scales exist, to compress probabilities and consequences into something a non-specialist can hold. The early days are like hurricane season. The cone of uncertainty is wide, then tightens as the data gets better. Honest updates say, could when will isn't earned. Tell the truth you have, not the drama people can invent. A veteran of public briefings likes to say. The difference between those two lines is the difference between preparation and panic. Noise is inevitable. Social feeds love countdowns. Rumor loves vacuum. The antidote isn't secrecy. It's prompt, plain talk, and open data. Amateur astronomers, the folks in backyards, school domes, and community clubs, are surprisingly powerful here. They confirm positions on clear nights and swat down misinformation with something better than opinion, a telescope pointed at the thing itself. It's hard to argue with the sky someone just watched. On the ground, preparation looks less like a movie and more like a spreadsheet. If water is life, clean water is life twice. Portable filters, stockpiles of purification chemicals, backup pumps with pre-positioned fuel. Unglamorous, essential. If heat is health, grids get priority upgrades, hospitals get guaranteed power, and shelters get checklists for keeping people warm and air clean if dust ever becomes part of the story. If food is time, greenhouses, vertical farms, and low-tech grow tunnels by months where the sky might steal them. Lettuce under LEDs in a warehouse is no one's childhood dream. It's a bridge from one season to the next. Give me one winter you can plan for, says a resilience planner, and I'll show you 12 ways to make it livable. Coastal regions rehearse in a different key if an ocean strike is on any list. Tsunami models become bus routes and maps on kitchen tables. Sirens get tested. Evacuation corridors get cleared of that one fallen tree everyone has ignored for 3 years. Inland, the focus shifts. fire risk from thermal flashes, glass failure from shock waves, and the odd job of telling people that a bright sky event can break windows a long way from where anything hit. None of this is guesswork. We have small-scale precedents. A daylight fireball over Russia that shattered glass across a city. An airburst in Siberia, a century earlier, that flattened forest for miles. Those weren't cosmic doomsdays, but they taught us what shock waves do, what building materials hold up, and which ones don't. Now the difficult part, the one you can't solve with clever math alone. Ethics and geopolitics. Deflection is geometry with people underneath. When you push an object off a bullseye, you might slide its corridor over communities that weren't under it before. Early in a campaign, the keyhole, that small gate in space that leads to a later impact if you pass through it, can sweep across wide swaths of Earth. Every tiny tweak can shift who lives under a thin ribbon of possibility. Somebody has to sign for that risk. It's trolley problem meets orbital mechanics, an ethicist told me. You don't get to pick none. You only get to pick better. The cleanest answer is early detection, when the miss you buy is so generous that no one's ribbon lies under anything at all. The international machinery is quieter and more practical than most people expect. The groups that share observations and rehearse mission planning are small, collegial, and allergic to grandstanding. They run tabletop exercises with fake objects, real math, and baked-in disagreements. They practice the sentence, "We were wrong yesterday." Here's today's update, because fast-changing facts aren't failure. They're a sign the system is learning. Beneath those gains sits the uncomfortable truth that some laws will need emergency footnotes, not to bulldoze norms, but to make room for a kind of cooperation we haven't had to test before. Meanwhile, the science keeps squeezing meaning out of faint photons. If 3I Atlas starts shedding gas as it warms, we read its signature the way a perfumer reads top notes. A whiff of cyanide here, a breath of carbon there, sometimes sodium glowing street lamp yellow. If the halo around it, the coma stays stubbornly quiet when the recipes say it should be loud, that's a hint the surface is crusty or depleted. That matters because a fluffy snowball can explode into confetti if you smack it. A denser monolith might need a stronger, riskier push. We're not moving a boulder, a navigation lead likes to remind new folks. We're moving a personality. Let's look fear in the eye for a minute, because pretending we don't feel it is how it gets loud. Interstellar carries a mythic charge, not from here, which our storytelling minds sometimes translate into on purpose. Fact, most sinister-looking alignments in the sky are just geometry doing geometry. Hypothesis, if something feels like reconnaissance, that's often our pattern-hungry brain doing laps. Speculation, if we use that unease as a nudge to fund surveys, practice drills, and stock the unsexy supplies, fear has paid rent. Picture the day of the nudge. The first impactor closes in, its camera streaming pebbly gray frames at a frantic cadence. Then, static the expected kind. A heartbeat later, the numbers bloom. A spike in brightness where dust erupted. A whisper-small change in the object's path that only patient math can see. The room breathes. Nominal, someone says, and it's the sweetest word in aerospace. The second craft is already inbound, time to catch the object at the point in its spin where a tap does the most good. A third sits on a pad, fueled and ready if the latest solution says, more. Inches here become miles there. You don't win the whole game in one play. You move the scoreboard in your favor. If the updated trajectory says, we got it, the next act is studiously uncinematic. No parade, no triumphant speeches. A debrief. What did the last frames of video reveal? Did the dust plume match our models? Did the interior behave like meringue or like marble? How did the guidance software handle the final, jittery seconds? Bottle all of it for the next time, because there will be a next time, even if it's decades away. And don't waste the moment. The surveys receive steadier funding. Launch manifests get a break-glass line item. The public's casual fondness for space stuff, it's nudged towards something sturdier, like trust. If the numbers say, not enough, the honesty continues. You don't spin. You pivot. That could mean a more forceful attempt if the window allows. Or it could mean shifting to protection on the ground. Evacuations where water will run roads inland, fuel where cold will bite hardest, medicine where supply lines are thinnest, and light where growing seasons are fragile. That isn't defeat. That's what resilience looks like, when you admit nature gets the last word sometimes. Hurricanes, wildfires, earthquakes, we already live with big hands on small maps. This is new mostly because we haven't had to do it in living memory. The toolbox is familiar: logistics, coordination, care. There's a softer layer worth naming. If 3I-ATLAS comes close enough, even safely, it becomes a sky event, the kind that pulls neighbors outside at dusk. Kids will be wrapped in hoodies and pointed toward a ghostly smear with a tail. Phones will rise. Someone will pop a question on a rooftop because the cosmos is showing off, and we are who we are. Wonder isn't a distraction here. It's glue. It keeps communities steady when headlines rattle. Awe and agency aren't opposites. A psychologist said to me once, awe keeps you breathing while you take the next right action. By now you've felt the balance we keep. Facts in one pocket, what ifs in the other, and a modest joke in the cup holder to keep hands from shaking. It's not an accident. It's the only way to talk about big risks without turning into either a cheerleader or a doomsayer. The truth is both sharper and kinder. The chance of a serious impact in any given year is tiny. The consequence if it happened would be big. That pair doesn't argue for panic. It argues for preparation so boring, you barely notice it until the day you do, and you whisper thanks to people you'll never meet who kept the spreadsheets tidy. So if 3I Atlas were actually lining up on us, what would really happen? We'd keep the 3 clocks in view and fight to make the human one run as fast as the physics one does. We'd design for the object we measured, not the one we imagined. We'd speak in complete sentences, early and often, even when the update is no change. We'd make room in the plan for a slam of metal into a speck and for the hum of a greenhouse outside Omaha. We'd let curiosity and competence share a desk. And after, because there is an after, either way, we'd clean the room, label the cables, and write down what worked. We'd tape another note to the fridge of civilization. Watch the sky, answer the phone, help your neighbors, keep your sense of humor, thank the night shift people who guard the quiet. None of that depends on whether 3I-ATLAS misses by 1,000,000 kilometers or 1,000. All of it makes us the kind of species that deserves to keep telling stories under a sky that sometimes throws curveballs. Picture the moment it begins. A quiet control room, the kind with coffee stains and sticky notes, and a wall of monitors showing star fields like static. On one of them, a pixel nudges sideways between frames. It's not much, just a faint point that refuses to sit still while the universe around it behaves. Someone marks it. Then someone else checks the same patch of sky from a different telescope. The dot moves again. Fact: when a point of light slides against the fixed backdrop of stars, it's not a star. It's something closer: an asteroid, a comet, a visitor. The first whisper travels. We've got motion. The early hours are all rhythm. Observe, report, confirm. Dots become coordinates. Coordinates become a rough path. That path is fed to a clearinghouse that lives for nights like this. The place where the worlds, skywatchers drop their measurements so one big brain can stitch them together. If the numbers hint that the orbit isn't a loop around our sun but a swoop from far away, hyperbolic path, there's a second whisper: interstellar. Hypothesis: it's another traveler from other stars, like the ones we've met before. Speculation: it could be 3I-ATLAS, The kind of name that sounds like a serial number with a heartbeat. With a handful of sightings, the future is fuzzy. Picture a ribbon around Earth, impossibly thin, like a piece of tape wrapped around a globe. That's the risk corridor, the narrow track where the object might pass once you account for measurement blur. Early on, that ribbon can sweep across entire oceans and continents. It's not a prophecy. It's a question mark with a map attached. Every new observation narrows it. We don't predict once, as one orbit calculator likes to say. We predict, learn, and predict again. You'll hear two tools mentioned, because they fit in a sentence: a brightness curve and a color clue. The brightness curve is just how its glow rises and falls as it spins. That up and down tells you about shape and rotation, whether we're dealing with a lumpy potato or something more round. The color clue comes from looking at different slices of light bluish versus reddish to guess what the surface might be made of. If radar can ping it, not always possible, we get a tape measure for distance and a speed gun for motion. Fact: more independent measurements beat one fancy one. Hypothesis: if the object is dark and fluffy, like a dirty snowbank, it will brighten quickly as the sun warms it. If it's compact and crusted, it might stay shy longer. Speculation: shy or not, the path matters most right now. Public messages start simple, on purpose. The scales exist to pull panic out of probability. A low number means, watch but don't worry. A higher one means, we're paying attention for a reason. The cone of uncertainty, the same idea you know from hurricane maps, shrinks as days pass. Honest briefings say what's known, what's not, and when the next update lands, tell the story in pencil until the data hands you ink, one mission communicator says. The guiding promise is that corrections aren't confessions. They're the system doing its job. That doesn't mean quiet. Social feeds are devouring machines, and they love a countdown. Rumors bloom in the dark like mushrooms after rain. The counterweight is light, not just from big observatories with mountaintop domes, but from the quiet army of amateurs who can point a scope, take a clean image, and share it with the world before breakfast. It's harder for misinformation to survive against 1,000 backyard truths. You can argue with a headline. It's tougher to argue with a picture your neighbor took. Meanwhile, the object is getting louder in the language telescopes speak. If it starts shedding gas as it warms, and comets often do, a ghostly halo forms around the nucleus. A fuzzy coma with tails that point away from the sun like chalk dust blown off a blackboard. Not all tails are equal. One is dust, pale, curving, pushed gently by sunlight. Another is ionized gas, thin, blue-green, yanked straight by the solar wind. Occasionally there's a third, sodium yellow, a delicate exhale you only see with the right eyes. Fact: that beauty is chemistry and sunlight playing together. Hypothesis: a strong, early tail means the surface has easy-to-melt ices. Speculation: if it stays stubbornly quiet, either the crust is tough or it's not the comet type at all. Geometry can trick you. If Earth happens to line up just right, sunlight scatters forward through the dust and turns a modest comet into a showstopper. People have seen comets in daylight under that magic angle. But geometry can also hide things. When an object approaches from the sun's direction, ground telescopes are nearly blind. The glare washes the field clean. Spacecraft with Coronagrus fancy sunglasses for the sun step, and then watching for anything that slips through the bright veil. The universe loves to bury the lead in sunlight. A solar physicist jokes. In the first week, the "is it us?" question never leaves the room. Not because anyone likes drama, but because early choices matter. If the risk corridor still threads the globe after several nights of data, teams start sketching playbooks. They're mostly checklists. Who can get time on which telescope? Which space missions can pivot to look? What launches are on the calendar that could, in a pinch, carry a small scout to fly past and sniff the surface. Fact: we can build a fast, simple space camera from parts we already know. Hypothesis: a single close-up of texture crumbly versus compact could decide which nudge makes sense. Speculation: we'll get that picture if the window stays open. You may hear a new term: keyhole. Imagine a tiny gate in space. If the object passes through it during this pass, gravity sets it up to come back later on a collision course. Keyholes are small sometimes, a few hundred meters wide, but the stakes are large. That's why some plans aim not just to miss Earth now, but to miss the gate for later. We don't want to win the inning and lose the game, says a navigation lead who thinks in seasons, not plays. Humans are part of this physics. Cities test sirens in coastal towns, just in case an ocean strike scenario ever lands on a contingency map. Hospitals check generators, because cold and dark are the enemies you can beat with diesel and diligence. Water managers run their if the grid hiccups routine. None of it means an impact is expected. It means professionals do drills when the rest of us are sleeping. Preparedness is what science buys you when certainty is still on layaway. A resilience planner likes to remind council meetings. The question that gnaws, the one that turns a night sky story into a dinner table debate, is the alien whisper. Interstellar sounds like intention, even when it isn't. We're pattern hunters. We see meaning in tea leaves and constellations, and the route a comet takes. Fact: objects from other stars don't owe us a neat backstory. Gravity flings debris the way a campfire throws sparks. Hypothesis: if a path looks convenient for sightseeing, that often reflects where we were able to watch from, not a plan. Speculation: if we ever do find intention, it won't be because a trajectory felt planned. It'll be because instruments caught a thing nature doesn't make: materials, signals, shapes that pass the science sniff test. Until then, we owe the sky our curiosity and our restraint. A strange thing happens in these first 7 days. The object that began as a pixel becomes a character. It acquires a spin rate, a temperament, a reputation in Slack channels and late-night texts. People root for the math to behave, for the corridor to slide away from blue and green and into the safe white of empty ocean, or better, into empty space. They also root for the story to hand them something beautiful, a tale to point at with a kid, a reason to step outside at dusk and say, "Look up." It's possible to want both, and to get both. When the update arrives, the one with fewer maybes and more periods, it won't read like a plot twist. It'll look like a spreadsheet with smaller error bars and a simple sentence at the top: path adjusted, corridor clear, impact ruled out. Or, in the tougher version, corridor persists. Options under review. Next update at... Either way, the next steps are the same. Keep watching, keep reducing uncertainty, keep choices ready. The dot that moved becomes a test we pass together, not by heroics, but by the slow, competent weight of many small truths added up. And if, in the end, 3IATLAS is just another traveler that barely tips its hat as it passes, we still win. We get spectra to decode, dust to model, a better sense of how often stars throw us their leftovers. We get a sharper pencil for the next ribbon we draw around the planet. We get practice telling the truth in public without turning the dial to panic or lullaby. Maybe most of all, we get a reminder that being small under a big sky doesn't make us powerless. It makes us precise. Suppose the update doesn't hand us the clean, boring answer. Suppose the ribbon around Earth refuses to slip away. Not dramatic, just stubborn a hair's breadth that won't stop hovering over maps while the coffee goes cold. The room shifts from let's watch to let's plan, and the energy turns from chatter to chess. This isn't movie trailer panic. It's clipboards and calendars, and the quiet hum of printers as teams build a path from maybe to miss. The first reality everyone accepts is that time is a propellant. Early is easy, late is hard, says a mission planner whose desk is a shrine to sticky notes. A tiny nudge now can become a big miss later, the way a fingertip on a rolling coin can keep it from falling off the table's edge. But what kind of fingertip do you use? You don't pick a tool before you know the thing you're nudging. If it's a brittle snowball, one kind of shove works. If it's tough as a bowling ball, another. That's why Know Thy Rock becomes the anthem. A small scout probe, basically a camera with a brain, can ride a fast ride share and meet the visitor up close, sniffing the gas around it and photographing texture, powdery, crusted, cracked, or smooth. Fact: a single close-up can change a decision. Hypothesis: if the surface looks like pressed talc, a gentle push might be best. If it looks like a welded brick, a sharper tap might be safe. Speculation: in a tight timeline, one good picture is worth 1,000 conference calls. Meanwhile, the sky begins to join the story. Word filters out that the visitor is visible in amateur telescopes at dusk. In clear towns, people wheel out tripods after dinner. The first photos appear tiny fuzzballs with a hint of tail, like a candle blown out in slow motion. Some nights the tail looks curved and creamy. Other nights it thins into a narrow blue line. That's sunlight and the solar wind dividing the spoils. Dust pushed gently, gas yanked straight. If Earth happens to line up just right, the whole display can flare brighter than anyone expected, because light scatters forward through the dust. A comet can turn day proud for a while under that geometry. It's the oldest magic trick, laughs a comet watcher, the sky holding a mirror at just the right angle. Fact: brightness doesn't mean danger. It means geometry and chemistry got lucky. Hypothesis: a strong early tail hints at ices near the surface. Speculation: a quiet coma could mean the crust is stubborn, or the core is different from what we thought. Back under fluorescent lights, words like windows take on new meanings. There are windows to observe, windows to launch, windows to decide. A launch window is the short slice of time when a rocket can leave and still meet a moving target. Miss it, and the next one might be days away or months. You can't thread a needle from a carousel horse, says a navigator, unless you know exactly when to reach. So teams build decision points backward from the latest possible safe launch. If the corridor is still brushing Earth by that date, a nudge mission gets a green light. If new observations clear the path earlier, the mission stands down and the champagne is observational, not celebratory. Public briefings become a rhythm, like sports scores in the background. The language stays plain on purpose. A small number means probability, not prophecy. The maps show the ribbon narrowing day by day. We draw in pencil, one spokesperson says into a microphone, and the data sharpens the line. Alongside the briefings, there's a second track that never makes headlines because it's not exciting. It's cities checking generators and hospitals, confirming fuel deliveries. It's water utilities doing the boring hero work of flushing lines and testing backup pumps. Not because an impact is expected, most of these corridors end up slipping off the globe, but because drills are cheaper than regrets. Fact: you can practice resilience without summoning disaster. Hypothesis: the same cold weather plans you use for blizzards help if the grid hiccups. Speculation: the world gets better at this because we keep doing it for many kinds of storms. In the planning rooms, you may hear a polite word with sharp edges. Keyhole. Imagine a tiny invisible gate in space. If the visitor passes through it on this pass, gravity sets up a future meet-cute you don't want. The fix, if needed, is to nudge not only to miss Earth now, but to miss that gate later. In the future as well as the present, mutters the quiet engineer who keeps drawing circles on circles. Fact: those gates are small, but the math is real. Hypothesis: a millimeter per second change today can move you a whole city's width by next year. Speculation: small pushes are elegant. Big pushes are brute force you save for late innings. If the visitor is the crumbly kind, there's another possibility. It sheds pieces on its way in. Not because it hates us, but because sunlight and spin tug loose factories of dust. That's gorgeous through a telescope and harmless at a distance. But if fragments get big enough and the geometry turns mean, you plan for airbursts, the kind of high-altitude booms that break windows but don't make craters. That's when agencies in charge of alerts lean on what they learned from falling meteor events in the past. Don't gather at windows. Step away from glass. Treat bright streaks like lightning beautiful, but not something to watch without thinking. Curiosity is natural, says an emergency director, but so are seatbelts. There's also the ocean question, the one that nudges maps from greens and browns to big empty blues. An object hitting open water turns energy into waves. Coastal communities already drill for tsunamis born from earthquakes. They update route signs and practice uphill walks when someone rings a bell. The physics of a space-made wave are cousins to the quake kind in all the ways that matter to people on foot. Move inland. Move high. Don't drive if the roads choke. The details, how big, how fast, belong to modelers. The advice go now belongs to whoever loves you. Fact, water is patient and strong. Hypothesis. A mid-ocean strike spreads energy far but thin. Near-coast strikes are Messier. Speculation. You never regret knowing the hill you'll run to. As the visitor brightens, a strange calm can settle over the whole thing, a quiet that isn't denial but focus. The teams stop arguing about labels and start talking about plumbing details. The exact second to fire a thruster, the angle of a camera, the timing of a press release. Probability is not prophecy, says a soft-spoken analyst who has seen too many weather tracks to be impressed by one more cone. It's a sentence that does a lot of work in people's heads. It leaves room for awe without surrendering to fear. This is also the stage when the alien whisper gets its last, loudest push online. Because a straight path looks like a plan if you squint emotionally. But straight paths are how gravity works when nothing gets in the way. And a neat sequence of flybys looks inevitable after the fact because we only remember the interesting ones. The communicators stick to their lane. If we ever catch something nature doesn't make materials out of place, signals with structure, shadows with corners, you'll hear about it with receipts. Until then, the story is rocks and ice, sunlight and patience, math and margins. And if the ribbon finally does what most ribbons do, slides off the map and takes the goosebumps with it, the strange calm gives way to something lighter. The object becomes a show, not a threat. People step outside after dinner and look up from their phones for a few minutes. Someone lifts a child to see a smudge with a tail. A teenager takes the best picture anyone in their family has ever taken of the night sky. The teams who didn't sleep last week sleep now, a little proud and a little invisible. We love it when we're boring, a flight dynamics lead admits, half smiling. But let's hold the harder branch of the fork for one more heartbeat, the version where the ribbon stays on us longer than comfort likes. In that fork, the next week becomes a braid of 3 strands. Watch tighter, decide sooner, speak clearer. The watch tightens with more measurements from more places, because 1,000 small truths drag a big uncertainty into the light. The decide sooner piece means a simple mission might leave on a short fuse to give a gentle push you won't feel, delivered long before anyone needs to duck. The speak clearer piece is the one that earns or loses trust. It sounds like this. Here is what we know today. Here is what might change tomorrow. Here is what you can do that helps, even if all you do is keep living your life while others do their jobs. In both branches, the last shared act is the same. We step outside under a black ceiling salted with stars, and remember that being small is not the same as being helpless. We are the species that taught rocks to talk to other rocks across the void. That turns sunlight into power and power into tiny steering nudges that you can't see with your eyes, but you can feel in your bones when the update finally lands. Whatever this visitor turns out to be, show or shove, lesson, or lullaby, we meet it with our best mix of humility and craft. If the conversation shifts from, "Is it real?" to, "What do we do?" the toolbox opens quietly, almost politely. No capes, no lasers. Just physics that works the way a grocery cart works when you lean on it long enough. The trick is not brute force. It's timing. If you tap something early, a nudge as small as a fingertip can grow into a citywide miss by the time it reaches Earth's orbit. That's not poetry. That's how motion stacks up over distance. Fact: in 2022, NASA slammed a vending machine-sized spacecraft into a tiny moonlet called Dimorphos and changed its orbit by 33 minutes. That's a proof of concept you can hang your hat on. Hypothesis: that momentum bonus, a kick from debris blasting off the surface, works best on crumbly targets. Speculation: if 3IATLAS turns out to be tougher than it looks, we'll need a push that's more like a tug than a punch. Kinetic impact, the space elbow, is the cleanest story to tell. Point a fast little spacecraft, hit the bullseye, and let the physics do the rest. But even the simplest plan needs homework. What are we hitting? Powdered sugar or peanut brittle? Is it spinning like a lazy top or flipping like a shoe in a dryer? That's why the first launch is often a scout. A one-camera detective that can arrive early and send back the two pictures that matter: surface texture and spin. From those, you can choose how hard to tap and from which side. Know your rock. Save your mission, mutters a guidance engineer who has a personal relationship with coffee. There's also a calmer, slower option that sounds like science fiction and behaves like a tugboat: the gravity tractor. Park a heavy spacecraft a short distance from the object. Hold position with whisper-thin thruster puffs and let mutual gravity do the work. It's like hovering next to a drifting canoe and coaxing it sideways by holding a rope you can't see. The upside is exquisite control. No fragmentation, no flying shrapnel. The downside is time. You need months or years, the way you need Sunday afternoon if you plan to smoke a brisket. Fact: tiny continuous forces add up. Hypothesis: if we meet 3I Atlas early, a hover and tug could paint the safer lane without breaking anything. Speculation: we'll end up using both tap first, tug for polish. Then there's the tool in the bottom drawer, wrapped in legal tape and moral caution: a nuclear standoff. Not a boom in the middle, that's a terrible idea, but a detonation a short distance away that flashes a thin layer of the surface into vapor and kicks the object the other direction. It's the world's spiciest airbrush. Almost nobody wants to reach for it, and plenty of people will argue the paperwork is harder than the engineering. But it stays in the drawer because late is hard and big is hard, and sometimes those two show up together. Fact: standoff detonation can, in theory, deliver orders of magnitude more push than a kinetic tap. Hypothesis: it becomes thinkable only if warning time is measured in months and the diameter in kilometers. Speculation: the conversation will be as much law and diplomacy as it is propulsion and target geometry. There are weirder ideas that sound clever because they are. Ion beam shepherding. Park nearby and blow a focused stream of ions at one side, sandblasting atoms into a ghost-thin rocket plume. Mass drivers. Scoop the object's own material and fling it off like a pea shooter, each puff stealing a little momentum from the parent. It's recycling, jokes a propulsion lead, but for destiny. These methods love long timelines and reliable power. They hate surprises. If 3IATLA telegraphs its approach early years, not months, they move from whiteboard to workshop. All of this depends on catching the visitor before the calendar turns unfriendly. Early is not just easier. It's cheaper, cleaner, kinder. We don't chase the ball, says a navigator with a baseball cap and a deadpan delivery. We run to where it's going to be. That's where launch windows become characters in their own right. You don't get to leave whenever you feel inspired. The path is a moving thread, and the needle only lines up occasionally. Miss a morning, and your next chance may be a season away. This is why decisions have timers. You don't argue until midnight when the rocket needs to roll at dawn. And then there's the thing the public rarely sees, the ground game that makes the space game possible. A deflection mission rides a stack of ordinary miracles, propellant lines that don't leak, valves that open, guidance software that doesn't blink when starlight flares. Engineers build two of everything that matters and strap good luck into the third seat. Redundancy is romance. Laughs a systems lead, tapping a checklist that looks like the Rosetta Stone for anxiety. Fact: simple missions succeed more often. Hypothesis: a single well-aimed tap beats a Rube Goldberg ballet if the clock is tight. Speculation: we learn enough in the first attempt to do the second with our eyes half closed, if we need it at all. While the tools get chosen, communication stays stubbornly human. No threats, no lullabies, just plain talk. If a corridor overlaps Earth on Tuesday and not on Friday, people deserve to know both, and they deserve to hear what changed. The language stays careful because words are steering tools too. Probability is not prophecy, becomes a refrain. Near on a chart isn't certain. Safe doesn't mean we stop watching. The goal is to give you a clean way to live your day without pretending nothing's happening. Maybe that looks like moving a coastal festival to higher ground, just in case, or staging generators near a hospital, because why not? Preparedness is just competence in a sturdy coat. Suppose, in our thought experiment, the call is made. Launch the nudge. The rocket goes at night because the air is cooler and the winds play nicer. A rising flame becomes a shrinking star, and then the ground teams do the same thing everyone at home does. After a long day, they wait. A month later, the tiny spacecraft wakes the object with a flashlight and a whisper. The first close-ups arrive like postcards from a cousin you weren't sure was real. The surface is either fluffy or fused. The jets are either lazy curls or sharp knuckles. Those images pull another lever: final targeting. If a bright vent is spraying like a leaky hose, you don't punch there. You use it. Hit off center and let the natural outgassing add its own small torque to your push. Surf the physics, says the guidance lead, and for once, no one rolls their eyes. Impact Day looks nothing like the movies. There is no soundtrack, only telemetry. Crosshairs creep over a pebble field that is actually a mountain range. Numbers tick. The last photo is a blur, then a gray screen, then cheers that sound more like relief than victory, because relief is honest. Minutes or hours later, the math catches up. The track has shifted by a whisper that becomes a shout a million kilometers downstream. The corridor moves off the map, like a storm veering back to sea. And if it hasn't yet, the options don't vanish, they multiply. A second tap can refine what the first began. A gravity tug can take over to finish the job with quiet hands. Even the most cautious voice in the room exhales. We should also admit a truth that grown-ups can handle. Sometimes you don't get all the time you want. If warning is short and the visitor small enough, the best play might not be in space at all. It might be in town. Airburst physics favors windows over walls, so the advice is simple and unglamorous. Don't stand behind glass. Look away from the flash. Follow the same shelter-in-place guidance you'd use for severe weather. If the threat is to the coast, the guidance looks familiar too. Move inland and up. Don't wait for the second wave. Don't drive into a jam, because the sea does not negotiate. Fact: drills turn nerves into muscle memory. Hypothesis: the places that practice for storms adapt fastest to cosmic ones. Speculation: we'll discover that the skills we built for blizzards, wildfires, and hurricanes were planetary defense skills wearing local names. Through all of it, the sky keeps doing what the sky does, gliding over our heads, quiet, enormous, indifferent. And we keep doing what we do, checking, measuring, deciding, explaining. Maybe 3 IATLAs ends up as nothing but a beautiful streak in 100 family photo albums. A visitor whose souvenir is a night you actually looked up. Maybe it becomes the reason we rehearsed and the proof that rehearsal mattered. Either way, the story works best when it stays human. Make the call early. Pick the simple tool first. Tell the truth in sentences anyone can carry. And remember that a millimeter today can be a continent tomorrow. The first clue wouldn't arrive with a siren. It would arrive as a faint smudge that doesn't behave like the others. A survey telescope takes a picture, then another. And in that little difference between two frames, like a spot the difference puzzle you did as a kid, there's motion. Not the slow, polite drift of a main belt asteroid, but the quick, purposeful stride of something on a steep path. That tiny change sets off a chain. More telescopes turn, more images stack up, and a computer fits a curve through the dots, the way your brain completes a half-drawn circle. That curve is an orbit, and for new objects, it begins as a guess wearing a confident face. Here's where the uncertainty comb enters the chat. Imagine you're trying to predict where a tossed set of car keys will land after someone flicks them behind the couch. You know direction and speed roughly, but the landing spot is a fuzzy region, not a pinprick. In space, that fuzzy region stretches into the future like a long, tapering megaphone. Far away from today, the mouth of the megaphone is wide. You could fit continents in there. Closer to today, it narrows. Fact: every new observation tightens that cone. Hypothesis: if 3i Atlas is dim and fast, the cone starts out comically big. Speculation: the first 72 hours will feel like a weather forecast for a storm that might be in your county, or your neighbor's 3 states over. And numbers that reach the public need to act like good neighbors too. The Torino scale, a simple 0 to 10 color bar, translates astronomer into human. 0 means we checked. It's fine. 1 means keep an eye on it. Anything above that means it's time to move from curiosity to logistics. Most objects drop to 0 as the math improves. That's not a cover-up. That's how measuring works. Probability is not prophecy. And orbital dynamics lead likes to say, it's a snapshot of our ignorance, and the snapshot gets sharper. How does it get sharper? The same way you win at darts. You step closer and you light the board. Telescopes with bigger mirrors scoop more photons, which is just a fancy way of saying they see dim things better. A new generation of survey cameras revisits the whole sky quickly, connecting dots that used to be missed between cloudy nights. In space, an infrared eye checks for objects coming from the direction of the sun, the cosmic blind spot for ground observatories, by watching their heat instead of their reflection. Fact: hot things stand out in the dark. Hypothesis: a cold iceberg from another star still warms up a little as it nears ours. Speculation: the day we pair fast optical surveys with steady infrared watch, that we didn't see it coming, stories get rarer. When the object is bright enough, radar joins the band. A radar ping is just a radio shout and an echo. The time it takes to come back tells you distance, the way a canyon shout tells you how far the cliff is. The echo's pitch shift, the same effect that makes a passing siren rise and fall, tells you speed along our line of sight. With even one good radar session, the orbit uncertainty collapses like a badly pitched tent. No poetry there, just geometry. If radar isn't possible too far, wrong orientation astronomers get clever with what they have. They'll watch for an occultation when the object briefly snuffs out a background star. That blink gives you size and shape the way a shadow on a wall gives you the outline of a hand. Even with better and better numbers, a map you'll see on the news will look like a noodle, a skinny ribbon that wobbles across the globe, labeled with dates and times, shrinking as the days go by. That ribbon isn't where the object will go. It's where the center of the uncertainty could pass. It narrows because the math is breathing easier. It wiggles because small forces matter. Sunlight pressure is a nudge. Outgassing a gentle hiss of vapor from sun-warmed ice is a nudge. Even the way the visitor spins can add a slow, stubborn bias. Fact: small pushes add up over millions of miles. Hypothesis: a dark, dusty surface gets pushed differently than a clean, icy one. Speculation: the first close-up images from a scout probe could change the map more than the last 10 nights of distant photos. There's a rhythm to the updates once the world is watching. Mornings, UTC, bring new astrometry, the measured positions posted to the clearinghouse where everyone, from a university scope to a backyard wizard with a remarkable setup, can contribute. Afternoons bring revised orbits. Evenings bring briefings where an official points to a line and uses patient words. Confidence interval. Very low probability. Next opportunity to reduce uncertainty. The job here isn't to downplay. It's to show the gears turning in real time. We measure, we model, we update, says a survey scientist who has said it so often it should be on a mug. And yes, the internet will explode with certainty. You'll see screenshots with arrows drawn in red, proclamations with lots of exclamation points, and claims that the map moved because they know something. Here's the less spicy truth. The map moved because math is honest. A new observation that trims the uncertainty is like getting glasses. The room looks different because you can finally see the edges. Fact: transparency calms more than reassurance. Hypothesis: showing your work what changed and why keeps rumor oxygen low. Speculation: the best rumor antidote is a daily cadence and a single source of truth that never waffles on plain language. Behind the scenes, a dozen little teams spin up. One group runs what-if scenarios on a supercomputer, slicing the uncertainty cone into thousands of thread-like paths and noting which ones graze Earth. Another group checks for friendly launch windows, because physics is only helpful if the rocket can actually leave on the right day. A third group starts the social playbook. If this becomes a coastal event, who translates guidance into the languages that matter where it matters? Who calls the mayors? Who explains airburst in 60 seconds without scaring the dog? None of this is dramatic, and all of it is essential. Sometimes the hardest update to deliver is the happiest one. It's a miss. There'll be a temptation to throw confetti and declare victory, but the better move is to mark it down as practice that counted. We learned how the new surveys played with the old ones. We learned where our metaphors carried and where they snapped. We learned which graphs made sense to people who don't wear badges. Every near miss teaches aim, says a flight director who has lived through her share of long nights. And if the result isn't a miss, if the cone keeps kissing Earth no matter how tight we pull it, then all this measuring turns into targeting. The line you've been staring at on a map becomes a corridor to push aside. The same telescopes that found the thing become the instruments that grade our homework after we nudge it. The nightly cadence doesn't stop, it changes tone. Numbers grow a touch more urgent, the way a storm update does when landfall drifts closer to town. It's still math, still patient, still careful, just with sleeves rolled up. Underneath the play-by-play sits the simplest truth of the whole game. You can't steer what you don't see. Watching the sky isn't paranoia. It's maintenance, like glancing in your rearview mirror before you change lanes. We're not trying to outsmart the universe. We're just trying to give ourselves enough time to make small moves that matter, and to explain those moves in words that don't require a dictionary. If 3i Atlas remains a tourist, we get a good story and better tools. If it doesn't, we get the same story with the volume up and the tools we've been sharpening out on the table, where everyone can see them working. If the map refuses to budge and the line keeps drifting over our neighborhood, the conversation changes from, "What is it?" to, "How do we move it?" You don't steer a mountain. You nudge its future. The trick is time. A tiny push now becomes a wide miss later. The way a 1-degree turn taken miles before an exit drops you cleanly into the right lane instead of across three. Fact: change an object's speed by just a millimeter per second months in advance, and by the time it reaches Earth's orbit, that tiny tweak can translate into tens to hundreds of kilometers of sideways miss. Hypothesis: for something like 3i ATL is fast, possibly fragile. Maybe a few hundred meters to a few kilometers across earlier is everything. Speculation: the decision point that matters most will arrive while the public is still arguing about whether to worry. The least dramatic option is the one pilots love: station keeping. Park a heavy spacecraft near the visitor and let gravity do the slow work, like a tow truck that doesn't touch the car but still tugs it through sheer presence. Engineers call it a gravity tractor. You hover slightly off to the side and fire gentle thrusters to keep your place. The mutual pull between spacecraft and object makes a steady, polite bias in its path. It's exquisite for control and impossible to misuse, but it's also slow. Fact: a gravity tractor needs years to matter and works best for objects under a kilometer found well in advance. Hypothesis: if 3i ATLAS is discovered with less than, say, 2 years of warning at interstellar speeds, 45 to 70 kilometers per second typical, this method becomes a beautiful idea filed under next time. Speculation: we'll still design one, because once you've built a reliable tow truck for space, you sleep better. The headline-grabbing option is the shove the kinetic impactor. Think of it as a cosmic fender bender you plan on purpose. You slam a compact spacecraft, maybe half a ton to a few tons, into the object at several kilometers per second. That direct hit transfers momentum, and the plume of ejecta, the dust and pebbles kicked off the surface, acts like a rocket exhaust, amplifying the shove. Small push early beats big push late, says a mission designer who has built more rendezvous charts than coffee breaks. Fact: we've already proven this works on a harmless target. The shove was larger than the spacecraft's mass alone would suggest, because the dust kicked off gave an extra kick. Hypothesis: on a fluffy, icy surface like many comets, the ejecta plume could multiply the push by a factor of a few. Speculation: on a fragile, gravelly rubble pile, the same hit might bury itself like a snowball and waste precious momentum. Timing is the heartbeat. If the first viable launch window is 9 months out, you might stack several small impactors into a train, one after another, each adjusting the path and teaching you about the surface before the next arrives. That staggered approach buys learning and reduces risk. Miss the first, you still have the second. Hit the first and watch how the plume behaves before you pick where to aim the third. Fact: the travel time to intercept depends on where the object is and how heavy your rocket is. Typical flight times range from a few months to a year for inner solar system engagements. Hypothesis: for an interstellar visitor on a steep, fast track, you'll want a head start, ride no scenic detours. Speculation: the most valuable payload on the first impactor may be the camera, not the mass. Knowledge boosts every later shove. There's a hotter option, and it's always controversial: a nuclear standoff detonation, no Hollywood drilling, number landing, no fireworks on impact. You pop a device some distance away so the flash vaporizes a thin skin on the threat's sunward side. The vapor jets off and gives a mighty push. It's the difference between hitting a cue ball and hitting it while also blowing compressed air at it. This is a physics tool, not a weapon, says a veteran of high-energy systems. Fact: done properly, you don't fragment the object. You impulse it translated by vaporizing millimeters of material. Hypothesis: a fast-spinning, loosely bound comet nucleus might be less likely to shatter when you stand off than if you smack it directly. Speculation: international law and public tolerance may be the true limiting factors, not engineering. Every method runs on knowledge, so the very first responders are scouts. A small, fast probe sent early can do close-up imaging thermal mapping, and maybe a touch-and-go dust sniff. It's the space version of tapping a wall before you hang a shelf. Is it hollow? Is it chalky? Does it crumble? Fact: surface strength on comets can vary from crunchy snow firmness to powdery talc. Bulk density often sits in the 0.4 to 0.8 grams per cubic centimeter range, about as dense as packed snow or pumice. Hypothesis: an interstellar object might carry crusty radiation-hardened skin that hides a softer interior. Speculation: if the surface is coated in dark, carbon-rich grit, sunlight pressure will have been nudging it already. Your nudge plan should account for that slow, constant push. The atmosphere complicates everything if the timeline is short. If impact is months away and the size looks to be a few hundred meters, you have to decide whether disperse in air is safer than crater on the ground. For some stony asteroids, an airburst, an explosion high in the atmosphere, spreads damage over a wide region but avoids tsunamis or deep craters. For fluffy comets, breakup can begin higher, with multiple airbursts along the path. Aim to miss the planet, not to change how it hits it, says a risk modeler with a fondness for whiteboards. Fact: fragmenting a threat on purpose can multiply targets and complicate forecasts. Hypothesis: if your only option is late and blunt, a single big push that shifts the arrival time by minutes could make the difference between city and countryside. Speculation: a last-ditch nudge that trades a coastline for open ocean is the kind of choice you'd want every nation to sign off on first. Power and propulsion are the quiet heroes in these plans. High-thrust chemical stages get you out of Earth's neighborhood quickly. Efficient ion engines let you stalk your target and line up the hit with surgeon steadiness. Solar sails think giant, reflective umbrellas don't carry fuel at all. They sip sunlight and trade patience for speed. Fact: we already fly ion propulsion on deep space missions. It's precise and miserly with fuel. Hypothesis: pairing a chemical kick with an ion finish will become the default for rapid response deflection missions. Speculation: when sails get big enough, a lightweight scout could pace an interstellar object for weeks, mapping it like a paparazzo with infinite film. None of this happens in a single control room. There's an international choreography to aid observatories sharing astrometry, agencies negotiating rides, engineers merging standards, so bolts from one nation fit flange plates from another. You want to be arguing about bolt patterns now, not at L-10 days, quips a systems engineer who has the patience of a glacier. Fact: the world already rehearses impact scenarios on paper, running drills where the object changes course mid-exercise. Hypothesis: the first real deflection will succeed partly because of those dry runs. Speculation: the second will go smoother because the first taught us where anxiety lives in a schedule. Communication is a tool in the toolbox too. The public doesn't need equations. They need metaphors that carry weight without hype. A millimeter per second is a human walking pace spread across the gulf of months. A 1-minute arrival shift can move a crossing point by hundreds of kilometers at orbital speeds. Explain it like weather, a public affairs lead says. Show the cone, show how it shrinks, show what we're doing to make it shrink faster. Fact: panic wastes time and breaks logistics. Hypothesis: daily, calm updates reduce rumor and hoarding. Speculation: the right 90-second explicable repeated will do more to steady the ship than a 2-hour briefing that tries to be clever. There is no magic wand, but there is a plan, and it is not made of wishful thinking. It's a ladder. See early, measure better, learn fast, push gently, verify honestly, repeat. If we're lucky, 3I a TLAS remains a story we tell about preparedness, a time the cone narrowed to a near miss while we watched, learned, and slept fine anyway. If we're not lucky, the same plan becomes a checklist with timestamps and names, and the nudge we rehearsed in theory becomes a trackable, measurable change in a line on a plot. Either way, the goal is the same. Make small moves when they're cheap, so we never have to make desperate ones when they're not. Space doesn't care about our schedules. An old navigator says, eyes on a plot that looks like a bowl of spaghetti until you stare long enough. But it does reward early. That, in the end, is the heart of it. We don't have to be perfect. We have to be early, clear, and steady. And we can be. If the clock runs out and our little shoves don't add up to a miss, the story stops being about orbital lines and starts being about air, water, soil, and time. Impacts don't just hit a spot. They tug on the whole planetary web. The size of the visitor and the place it strikes decide how loud that tug will be. A few hundred meters across means a regional catastrophe with global aftershocks. A few kilometers turns those aftershocks into a long echo you can hear in every harvest, every ocean current, every monthly power bill. Fact: the air remembers. Pulverized rock and glass fine, dust lofted high into the stratosphere can linger for years because there's no rain up there to wash it out. Hypothesis: the grain size matters more than most people realize. Powder that's a fraction the width of a human hair is the real villain for long-lived dimming. Speculation: a fast, icy interstellar visitor splashing into a carbonate shelf or sulfur-rich sediments could spike the atmosphere with extra reflective particles, turning months of haze into years of muted daylight. A climate modeler puts it simply: photosynthesis is a fragile contract with the sun. Cut the light enough and plants default to survival mode. In a 500-meter case, you might see 2 or 3 rough growing seasons, worldwide shorter, colder, more erratic, followed by recovery as the sky clears. In a 3-kilometer case, the first year could be brutally dim, with slow improvement over 5 to 10 years. Fact: oceans damp the cooling a bit because water holds heat. Continents feel the shock more quickly. Hypothesis: the monsoons, those giant seasonal lung breaths that feed billions, would stumble and learn a new rhythm. Speculation: the new rhythm won't match old planting calendars, and that mismatch will feed as many headlines as the impact itself. Where it hits reshapes who suffers first. A continental strike front loads dust and fires. Forest canopies brown in weeks. Ash falls like gray snow. An oceanic strike spares vast swaths of land from direct blast and fire, but writes its signature in water. Tsunami physics is cruel and simple. Deep water hides a wave's height. Shallow water does not. You won't see a 100-meter wall in mid-ocean, but that energy still comes ashore, folded into a surge that rolls inland far beyond any storm tide line on a map. Fact: nearshore impacts weaponize geography bays funnel water. Deltas give way. Low-lying megacities face their worst day. Hypothesis: a mid-ocean strike reduces long-lived dust compared to rock. It increases immediate human displacement by the millions. Speculation: the insurance industry's vocabulary will feel suddenly too small. The biosphere responds in patterns we've seen in the fossil record and more recently in computer experiments. Fast crashes at the bottom of food webs, slow rerouting at the top. In the sea, tiny light-powered drifters starve first. Fish stocks follow. On land, lush ecosystems go brown, and the winners are creatures that can wait: seeds, spores, hibernators, and eat anything. Omnivores, decomposers. Life bends, says a paleontologist, but it hates being hurried. Fact: many species survive bad years. Diversity takes longer to heal. Hypothesis: refuges places with gentler microclimates and stored moisture become Noah's Arks. Speculation: the map of future conservation starts with old cave maps, spring maps, and fog maps. Humans sit in the middle of those webs with our own fragile contracts. Agriculture is the first one to tear. Grain belts face shorter growing seasons and more frost days. Fruit orchards lose entire years to ill-timed cold snaps. Fisheries stumble when plankton clocks go dark. Fact. Protected agriculture works, greenhouses, hoop houses, indoor farming with LEDs, but it drinks electricity like a thirsty marathoner. Hypothesis. Nations with robust controlled environment agriculture, seed banks, and fertilizer reserves bend instead of breaking. Speculation. Within weeks, lumens per calorie becomes a phrase you hear on evening news. Energy becomes the second contract under stress. Solar generation dips when the sky goes milk white, wind patterns shift, hydro seesaws as snowpack and rain change tempo. Gas and coal plants ramp to fill gaps. Carbon curves kink upward even as the world cools. Cold and dark is an expensive combo. A grid operator says with the voice of someone who has counted transformers in their sleep. Fact. Grids like predictability. Impact winters don't offer it. Hypothesis. Microgrids and stored heat district heating. Thermal batteries, hot water caverns buffer the shocks better than stretching already long transmission lines. Speculation. The old idea of neighborhood-scale resilience suddenly looks like modernity, not nostalgia. Public health moves with the air and the pantry. Fine dust can irritate lungs even at ground level. Smoke from impact-lit fires adds sting to the haze. Cold and cramped housing spreads respiratory infections. Fresh produce shrinks. So do micronutrients. Water systems, already delicate in many regions, juggle power outages, chemical contamination from fires and floods, and maintenance they can't get because parts are stuck behind broken supply chains. Fact. Clean water and heat avert more deaths than any high-tech gadget. Hypothesis. Simple interventions in 95s for dust. HEPA filters in shelters. Iodine and reverse osmosis at community scale buy time that money alone can't. Speculation. The most valuable cargo in the first month is not shiny. It's pipes, pumps, filters, glass, and grain. Mobility becomes a headache with ethics attached. Some places become temporarily poor fits for people coasts under threat. High latitudes under deep cold, arid regions with disrupted rains. Do you move people or move resources? You move both, and you argue less than you think, says a disaster logistics planner who has watched strangers load each other's trucks for years. Fact. Internal migration will outnumber international migration in the first year. Hypothesis. Railways efficient, forgiving, and already mapped carry the recovery on their backs. Speculation. Empty stadiums, mothballed malls, and big box shells become warm. Lit food factories faster than city councils imagine. Governance gets its stress test. Rationing calories, fuel, antibiotics isn't a word people like, but it's a tool that works when done fairly and explained plainly. Weigh the flour in front of the village, an aid worker says, meaning, be transparent or be replaced by rumor. Fact. Trust multiplies logistics. Rumor divides it. Hypothesis. Daily, boring, data-rich briefings beat dramatic weekly addresses. Speculation. The countries that do best will marry national coordination to local autonomy, letting towns route their own trucks inside a national highway plan. What about the sky itself? How long until blue is blue again? In the smaller scenario, the haze thins measurably after the first winter. By year 3, farmers are arguing about pests again, which is oddly comforting. In the larger, the second summer is still a pale imitation of normal. By year 5, the conversation shifts from surviving to rebuilding. By year 8, dim decade becomes a phrase historians use more than meteorologists. Fact. The atmosphere clears. It always has. Hypothesis. The path back runs through patient maintenance and the unglamorous work of patching roads, cleaning reservoirs, and reseeding fields. Speculation. A generation of kids will grow up thinking of food as a thing grown under lights as naturally as under the sun, and maybe that's not all bad for a warming world that follows. The economy learns new arithmetic. Luxury falls quiet. Essentials hum. Manufacturing tilts toward heaters, filters, pumps, LED drivers, glass, steel, and seeds. Robotics and teleoperated equipment, with people supervising from warm. Clean rooms keep minds and mills alive when the air outside is a chore. We'll see a lot of cleverness with cheap parts, says an engineer whose favorite store aisle is still the fastener section. Fact: duct tape, hose clamps, and standardized fittings solve 80% of early problems. Hypothesis: open hardware standards become as political as open data once was. Speculation: the countries that share designs and spares become hubs. The ones that hoard become sinkholes. Culture doesn't stop. It adapts. Dark skies, ironically, bloom with meteors from the debris stream. Astronomers weep and cheer into their thermoses. People tell shorter stories by lamplight. Music gets warmer, closer. Jokes get darker and kinder at the same time. We name the months of the first year in a new way: Ash March, Late Blue, Thin Harvest, because naming the hard parts makes them less shapeless. Fact: humans are excellent at making meaning when it's needed most. Hypothesis: shared ritual weekly neighborhood meals, lights out concerts, seed exchange fairs, does more than food alone to stabilize stressed communities. Speculation: on the other side, our habits won't snap back to 2019. Some of what we jury-rigged will become how we live. And there's a strange silver thread. Preparation for this kind of cold, dusty problem works for other problems too. Indoor farming that feeds a town during a dim year can also cool off summer power peaks when heat waves come back. Local water treatment built for uncertainty makes sense even when the taps run clean. Microgrids that carried a neighborhood through brown skies carry it through green storms. Resilience is brand agnostic, a city planner jokes. It doesn't care what broke the line. It cares that you had a switch. So, if 3i Atlas or any traveler like it ever made our planet flinch, the script would be difficult, but not blank. The pieces are known: dust that lingers, crops that sulk, seas that take their turn, grids that need patience, people who are kinder than they expected and more tired than they admit. The outcome isn't predetermined because the middle is ours to write. What we choose to power, build, share, and explain in the first 100 days decides what the 1000th day looks like. Stopping a fast, ancient traveler isn't about heroics. It's about schedule. If you have years, you can be gentle. If you have months, you start reaching for tools you hope to keep in their cases. The surprise of the last decade is that planetary defense has crept out of science fiction and into engineering notebooks. We've already tried one of the simpler ideas on a real space rock, and it worked. Fact: we've moved an asteroid on purpose. A small spacecraft slammed into a small moon of a small asteroid and measurably changed the moon's motion. You don't need to memorize the mission's name to get the point. The trick wasn't force so much as finesse. A clean hit at high speed kicked off a plume of debris, and that spray acted like exhaust from a rocket, giving the rock a bigger nudge than the spacecraft's mass alone could explain. An engineer's summary was disarmingly casual. Turns out rocks are pushable. Hypothesis: on many rubble-like targets, loosely held piles of stone and dust, that spray will do most of the work for us. Speculation: on unusually tough or icy interstellar objects, we may need to tune where and how we hit to get the same bonus oomph. The family of options starts with the kinetic shove because its simple hit it hard, a bit off-center, and let time do the rest. Think of a train switching tracks. Move the switch a few centimeters far from the station, and miles later, you've changed the destination. In space terms, a tiny speed change millimeters per second applied, years ahead, translates into a missed distance measured in thousands of kilometers. A mission designer puts it in bar napkin math. Early is everything. Fact: small nudges early beat big pushes late. Hypothesis: A campaign of several small impactors, staggered over months, may be safer and more controllable than a single monster hit. Speculation. If we ever faced a truly weird, spinning, lumpy interstellar object, the best play might be 2 hits from opposite sides to avoid a wild tumble. Next comes the slow tug the gravity tractor. Park a hefty spacecraft a respectful distance from the object and just hover. Gravity, the same quiet force that keeps the moon close, also tugs on the asteroid, and the asteroid tugs back. By angling thrusters so exhaust never hits the rock, the spacecraft can lean on it for months or years, changing its path with exquisite control. Tugboats don't drag ships by brute force. They nudge and hold them in place, while momentum and patience do the work. Fact. Gravity tractors avoid the risk of shattering fragile targets. Hypothesis. For objects discovered a decade or more in advance, a tractor can thread the needle between precision and politics. No explosions, no debris, just a steady pull. Speculation. A pair of tractors working in tandem, one to tug and one as a spare, could hedge against failures without adding much complexity. There's also the hairdryer approach, sometimes called an ion or laser shepherd. Instead of touching the rock, you gently blow on it, except the wind is a stream of ions or light that heats one patch, lofting material away as vapor. That vapor acts like rocket exhaust, pushing the object in the opposite direction. It's slow, but so is continental drift, and it gets there. Fact. Ablation, that gentle boil-off, turns the asteroid's own surface into fuel. Hypothesis. Focused beams from a nearby craft could aim for uniform, controllable thrust, avoiding spin-ups. Speculation. One day, solar-powered shepherds might be stationed in deep space, ready to meet surprise visitors halfway. The loudest option sits in the break glass in case of emergency box, a nuclear standoff. Not a Hollywood detonation inside the rock, but a precisely timed, precisely distanced flash beside it that vaporizes a thin skin of the surface. The vapor expands violently and pushes the object the other way. Think of popping a flashbulb next to a dusty wall. The dust jets away and the wall gets a shove. Fact. Nothing delivers more push per launch than a nuclear standoff, which is why it lives in every honest playbook. Hypothesis. Used at the right distance and angle, it can avoid fragmenting the target while still delivering a life-saving course change. Speculation. The real-world barrier isn't physics, but paperwork treaties. Trust and timing all have to line up under enormous pressure. Here's the part that decides which tool you actually pick. Time. The telescope network, those tireless cameras, scanning the sky night after night, buys you options. Detect an object 10 years early, and almost anything gentle will do. Detect it 2 years early, and you're rushing. But kinetic impactors and tractors still live in the realm of possible. Detect it 6 months early, and all polite conversation stops. As one mission planner says, when the clock is short, we don't choose what we like, we choose what works. Of course, not every rock is created equal. Some are monolithic, more like iron anvils. Others are sandcastles held together by gravity. Some spin slowly, some tumble like a dropped wrench. Their surfaces can be talc-soft or crusted over with sintered glass. Their insides can be empty honeycomb or stubborn stone. Fact. The first hours after discovery have to answer 3 questions: how big, how fast, what's it made of? Hypothesis. A quick reaction scout small, fast, and cheap launch within weeks could fly by, take the rock's temperature, map its spin, sniff the dust, and beam back the only measurements that matter: what kind of push it will accept. Speculation. With rideshare launches and off-the-shelf CubeSats getting better every year, those first responders could be pre-built and waiting. And then there's the tightrope between nudge it and break it. People worry understandably that hitting a target could create a shotgun blast of smaller bullets. The physics helps a little here. Most of the dangerous energy lives in the object's forward motion. A good deflection mission changes that path rather than smashing the thing to bits. If fragmentation does happen, most pieces inherit the same nudge and still misthink of a flock changing course with the lead bird. Fact: mission designs aim to shift a whole trajectory, not make cosmic gravel. Hypothesis: hitting at a particular angle on a particular side can minimize fragmentation while maximizing the push. Speculation: in late, last-ditch scenarios, it might even be wiser to aim for an ocean impact corridor, rather than a perfect miss if the window is too tight for clean deflection trading, a bad day for a survivable one. None of this happens in a vacuum well. Technically it does, but you know what I mean. The moment the math says, non-zero chance, phone lines light up across agencies and borders. Astronomers tighten the orbit. Radar dishes ping the newcomer. Spacecraft operators shuffle schedules. Someone in a windowless room draws a line on a map and frowns. Cooperation is not a luxury, a coordinator says. It's propulsion. Fact: the alert and response pipeline already exists, and it's faster than most people think. Hypothesis: practicing together tabletop drills, shared playbooks, pre-written contracts cuts months off the timeline when you need it most. Speculation: the first real deflection will be remembered as much for how nations behaved as for how the rock moved. And yes, there's the political knot. A nuclear standoff may be the only tool that can move a multi-kilometer object on short notice. But treaties were written for bombs pointed at Earth, not away from it. Same physics, different ethics, as one policy analyst shrugs. Fact: the law allows for emergency exceptions, but trust has to be earned long before the emergency. Hypothesis: a standing, internationally supervised planetary defense kit with clear rules, shared oversight, and on-the-shelf hardware would lower the temperature when decisions need to be made hot. Speculation: the first time we mount such a mission, the launch commentary will include as many translators as engineers. If all this feels like threading a needle while running, that's because it is. But the thread is real, and the needle has a big eye if you start early. The calm truth is that we don't need to be perfect. We need to be timely. We don't need to win against the universe. We need to teach a single rock to be slightly late for a meeting it would rather not attend. Fact: we've proven we can move a space rock. Hypothesis: with better sky coverage and a few pre-built playbooks, we can move the right one, soon enough, safely. Speculation: the first time we do this for real, it'll feel less like an action movie and more like air traffic control, a lot of math, a lot of murmured checklists, and then a quiet sigh when the numbers drift from red to green. So, could we stop it? If it looks like most of what nature throws, and if we see it in time, the answer is a careful, qualified yes. The rest is homework eyes on the sky, scouts on standby, shoves rehearsed, treaties tidy. The universe runs on blind momentum. We don't have to. Picture a visitor the size of a city block, about 100 meters long, dark as charcoal, moving faster than anything humans have ever built. That's the small end of interstellar traffic, a class of object many astronomers think is most common. If something like that lined up with our planet, the question wouldn't be end of the world. It would be, which city, what time, and how high in the sky does it break? That may sound cold, but it's how the physics plays out. Small doesn't mean harmless. Yet it does mean local rather than global. Let's keep it concrete. Two famous reference points on Earth set the scale for what small impactors can do. In 2013, a rock roughly the size of a house came in over Chelyabinsk, Russia. It never reached the ground. It exploded high in the atmosphere, and the shock wave raced outward like a giant clap. Windows shattered across 6 cities. More than 1,000 people were injured, mostly by flying glass, without a single crater in sight. Step back to 1908, to Tunguska in Siberia. That object was larger somewhere in the 50 to 60 meter range. It flattened trees across an area about the size of a small state. Again, no crater. The damage came from an airburst, a breakup and explosion as the object met thickening air at hypersonic speed. Now scale that story up to a visitor about 100 meters across, racing in on an interstellar path. The energy climbs sharply with speed. The result could be a city killer, even if no hole is punched in the ground. Why do some explode aloft while others dig a crater? It's a tug of war between strength and stress. As a fast object plows into thicker air, the pressure at its nose skyrockets while the rest of it still thinks it's in space. If the material is weak, icy, fractured, or a loose pile of gravel, the pressure difference tears it apart. If it's tougher metal rich or monolithic, it holds together longer and gets closer to the surface before failing, or it may survive to strike ground. Shape and spin matter too. A long tumbling slab presents different faces to the wind, so stresses change second by second. One planetary scientist put it in kitchen terms. Is it a biscotti or a brownie? Biscotti cracks, brownie smears. That's why the first job after discovery is to figure out not just the path, but the character. Here's the reassuring part. A 100-meter visitor is not a climate story. It won't throw enough dust into the stratosphere to dim the sun for years, crash ecosystems, or freeze harvests. It is, however, a public safety story of the highest order if it happens over land. A high-altitude blast can shatter glass and collapse weak roofs across tens of kilometers. Thermal flash can ignite fires. The shock can damage bridges, power plants, and hospitals close to the blast track. If it holds together and hits, the crater might be 1 to 2 kilometers wide, with dangerous debris raining down and a blast wave that knocks down structures far beyond the rim. Over water, the picture changes in a way that surprises people. Movies teach us to expect giant, basin-wide tsunamis from any splash. Reality is subtler. A high-altitude airburst above the ocean couples poorly into the water. It's mainly an air shock that skims along the surface. A small impact that actually reaches the sea can generate local, dangerous waves, especially near coasts, but it won't typically raise walls of water across entire oceans, the way a landslide or a very large seafloor quake can. That said, ships, ports, and coastal infrastructure within a few hundred kilometers could be hit hard. The devil is in the depth, the angle, and the distance to shore. Warning time is the other lever that determines outcomes. Smaller, darker objects are hard to spot far out. If one approaches from the direction of the sun, ground telescopes can't see it until it has swung past the sun's glare, sometimes only weeks or even days before closest approach. Space-based infrared telescopes help because warm rocks in cold space glow against the black. So do smarter algorithms that can stitch together faint, widely separated sightings and shout, "Hey, this one is moving weird, look again." A veteran survey astronomer likes to say, "We don't need to see the whole path, just enough to know where to aim the next look." Could we deflect something this small? Paradoxically, yes, if we discover it early enough. This class is exactly where our gentle tools shine. A quick hit or a compact spacecraft designed to collide at high speed can nudge a target of this size by a measurable amount. And that tiny nudge becomes a miss over millions of kilometers of travel. If we have months rather than years, planners might launch 2 or 3 small impactors in a mini campaign to buy more confidence. If warning time is measured in weeks, it gets harder. You'd still try perhaps with a single fast dart, and if available, a backup. But with days left, the focus shifts from moving the rock to moving people. That's where emergency management enters. An airburst's blast arrives minutes after the flash. That window is small, but not zero. Automatic alerts: move away from windows, take cover. Do not stand in stairwells or doorways with glass, can drop injuries dramatically. As we learned the hard way in 2013, power grids may ride out the shock. Phone networks may not. Hospitals need surge capacity. Fire response becomes the limiting factor if the thermal pulse lights multiple points. Short version: the city you'd want to be in is the city that drills for earthquakes and wildfires, because many of the same instincts save lives here too. Let's separate what we know from what we're still guessing. Fact: small, fast objects can pack regional punch without touching ground. We have 2 modern examples and a century of physics to back that up. Fact: the global risk piece isn't on the table for a 100-meter visitor. That's cold comfort if it's your city, but it matters for policy relief can flow from unaffected regions. Fact: early detection shrinks casualties by turning a surprise into a plan. Better sky coverage, especially from space, is the single best investment for this class of threat. Hypothesis: most interstellar pebbles are fragile enough that they'll break in the air, shifting the balance toward airburst rather than cratering. That favors shelter guidance over crater evacuation for many scenarios. Hypothesis: a small, pre-built first responder probe, cheap, fast to launch, designed to fly by and characterize, could be the difference between guessing and knowing which nudge or warning to use. Speculation: one day, a network of shepherd satellites may loiter in deep space along common approach lanes, ready to meet the next fast traveler halfway. If that sounds like science fiction, so did moving an asteroid, until we did it. Another knot: communication. There's a human tendency to crowd windows when something bright streaks the sky. That's exactly when you want people to step back. During Chelyabinsk, an expert's postmortem was painfully simple. People went to look. The shock arrived. The glass came in. Clear, per-written messages in plain language, pushed through phones, radios, and loudspeakers, turned that lesson into action. And yes, there's a public rumor machine to manage too. A calm, what we know, what we don't, what to do. Script beats viral doom every time. What about Oumuamua, our first interstellar visitor? If something with those dimensions long, skinny, tumbling lined up with Earth, the outcome would still hinge on strength. A tough, metal-rich shard might punch lower, possibly to the ground. A fragile, icy one would likely burst midder. Either way, you're in regional disaster territory, not civilization collapse. That distinction matters. It means local governments and neighbors help first, nations help next. The world doesn't stop spinning. There's a quiet upside to facing this class of threat first. It's the one we're most ready for. The telescopes we're building, we'll find more of them. The playbooks we're writing, how to aim a small impactor, how to fly a quick scout, how to issue a blast-safe shelter alert apply directly. The gap we still need to close is plainly labeled time. More eyes on the sky, buy more choices. More choices buy calmer days. In the end, a small interstellar hit isn't a movie about planetary doom. It's a story about preparedness beating panic. A bright flash, a rolling boom, a hard day for one place, and then months of careful rebuilding. It would be a tragedy, but a bounded one and a wake-up call to take the next visitor more seriously and earlier. If you follow this story far enough, you end up not with telescopes, but with treaties and with people in suits arguing about whether pushing a rock counts as peaceful use. Space law wasn't written with last-minute asteroid shoves in mind. The backbone is the Outer Space Treaty of 1967, which says space is for everyone and bans nuclear weapons up there. Then there's the Partial Test Ban Treaty from 1963, which says no nukes in the atmosphere or in space, period. None of that anticipated a scenario where the most peaceful thing might be a carefully calculated burst of energy, a few hundred meters from an incoming object to keep a continent safe. As one space lawyer likes to deadpan, our rulebook is excellent for the games we thought we'd play. Let's sit at the table where those decisions would actually get made. First, the discovery drops. Observatories feed measurements to the clearinghouse that crunches orbits. The risk number ticks upward and refuses to drop as new data come in. That's the moment technical committees hand the baton to diplomats. There are two real-world groups designed for this handoff. The International Asteroid Warning Network. Think of it as the global heads-up. Here's what we see, and the Space Mission Planning Advisory Group, which is where agencies talk about what they could do. Neither signs launch orders. They advise. Governments decide, and deciding is where it gets thorny. The blunt truth is that any deflection, no matter how expertly planned, nudges the missed point across the map. If you act early enough, you move the point far off Earth, and no one argues. If you act late, even a successful push could shift the corridor from ocean to land, or from one country to another. That's not science fiction. It's geometry. An ethicist we spoke with put it in plain English. If doing nothing means everyone gets hurt, doing something means someone might get hurt less. That is not the same as cleanly saving the day. Now layer on the liability. Convention and agreement that says the launching state is responsible for damage its space objects cause. How do you apportion responsibility for an attempted rescue that changes who needs rescuing? The nuclear option sits in a locked drawer on the table. Every engineer in the room understands why. Energy density. A standoff detonation detonating at a distance, not touching the target, can vaporize a thin skin of material and use that expanding gas as a rocket push. In some timelines, it's the only tool with enough muscle soon enough. But unlocking that drawer isn't just a technical step. It's a legal and political earthquake. You'd need carve-outs or emergency resolutions, rapid verification to assure the world that the device is headed toward a rock and not a rival, and on-the-record transparency about yields, distances, and fail-safes. Trust is a system, not a feeling. A former non-proliferation official told me. You build it with procedures you agree on when the sky is clear. Even the friendlier tools bring politics with them. Kinetic impactors, the hit it with a smart refrigerator approach, are dual-use technology. A spacecraft that can precisely hit a small body at 6 kilometers per second is also a proof of concept for hitting satellites. Gravity tractors, the idea of parking a heavy spacecraft near the object and letting mutual pull slowly change its path, require long lead times and continuous operations in contested orbits. You can hear the diplomats already. Inspection rights, data sharing, telemetry access, third-party observers. If you squint, planetary defense starts to look like arms control with rocks instead of missiles. Timing squeezes everything. A math of deflection loves early action and punishes delay. But early action means acting on probabilities, not certainties. In practice, that means deciding when the impact probability is still small but not negligible, because waiting for beyond reasonable doubt might kick you into the realm of impossible to move. That's not a comfort zone for politics. Imagine standing at a podium. We are spending billions to push an object that probably won't hit us unless we don't push it. That's where scientific culture transparent uncertainty, confidence intervals, models with caveats has to meet public culture, which prefers yes, no answers. One mission designer jokes that the job is translating sigma into seatbelts. Equity lives in the details. Who gets a say when the potential impact zone crosses oceans and borders? Who carries the cost if the safest deflection path shifts the risk corridor toward a country that can't influence the mission plan? What if the optimal solution increases hazard for a region with little voice in global forums? The fairest answer begins long before any specific threat, pre-agreed principles and funds. Think global insurance rather than ad hoc charity. Think capacity building so that countries at risk can host sensors, participate in exercises, and contribute to decisions. A researcher from the Global South put it bluntly, don't only tell us where the rock is. Put us in the room before you move it. Public communication is not garnish here, it's infrastructure. Panic is an impact multiplier. Rumor outruns rockets. The playbook needs plain language briefings that separate observation from interpretation, from action. What's measured, what it means, what happens next. The messages must be honest about uncertainty without sounding evasive. They must be actionable without being alarmist. And they must be ready before emotions run hot. After one tabletop exercise, a participant's note read, "We rehearsed the spacecraft. We forgot to rehearse the microphones." That's a fixable mistake. There's also a mundane but pivotal question. Who pays and how fast? A serious deflection campaign is not a paper study. It's a surge of launches, tracking assets, new spacecraft built on crash schedules, and round-the-clock operations. The bill runs high, and it runs now. Waiting for budgets to snake through parliaments is not an option. That's why some in the field argue for standing lines of credit or pre-authorized funds tied to objective triggers, the way disaster relief budgets unlock after hurricanes. You want the money to move at orbital speed, not legislative speed, as one agency head quipped. Verification and transparency keep the room calm. Independent tracking from multiple countries reduces mistrust and error. Open navigation data-timed releases knock raw fire hose lets outside analysts check the math. Third-party audits, even after the fact, build confidence for the next time. And if the drawer with the nuclear key ever opens, on-orbit inspectors or co-hosted sensors can make the difference between global buy-in and global suspicion. This is less about idealism than it is about engineering the social system around the technical system, so both work under pressure. Suppose the worst happens. You try to shove, and the rock cracks. Fragments spread along the same track like a shotgun pattern. Options remain, but the timeline compresses. Smaller pieces can sometimes be herded with follow-up hits. Evacuation plans shift from maybe to now. Civil defense protocols move to the front of the line. In legal terms, you've done everything rational actors would do. In human terms, you still own the consequences. That's why mission designs increasingly include fail-soft thinking angles that bias debris into safer corridors. Campaign plans with stop points where you reassess rather than plow ahead. It's tempting to see all of this as a burden, a tangle of rules, slowing a clean, heroic move. But the opposite is true. Clear frameworks, pre-negotiated lanes, and shared drills are what let you act fast without blowing up trust. The quiet work before any crisis, the mock pressers, the red teaming, the legal memos that say, if X, then Y, is what turns a global argument into a global response. The most useful sentence you'll hear from an expert in peacetime is, here's how we'll decide when the clock is ticking. So the question, what if 3 IATLAS were headed our way, isn't just about telescopes and thrust. It's about whether we've built a world that can choose under pressure. It's about whether nations agree in advance that saving lives together is worth accepting shared risk and shared credit. It's about whether we can hold two truths at once, that space is for everyone, and that sometimes someone has to lead openly, verifiably, and with the consent of the rest. The rock doesn't care how we answer, but our future does. Picture a quiet control room at 2A. Coffee gone cold, monitors humming, and the heavens scrolling by one snapshot at a time. Night after night, giant cameras sweep the sky, looking for dots that shift ever so slightly between frames. That tiny drift is the whole story. Most of those wanderers are harmless main belt asteroids, plodding along their lanes like commuters. A few are near-Earth asteroids, the lane changers we track carefully. And once in a long while, something arrives fast and foreign, cutting through our neighborhood on a path the solar system didn't write. The future we're building is about catching those rare visitors early enough that the ending is ours to choose. If you've heard people mention Rubin, that's shorthand for a new breed of survey telescope that turns the entire sky into a living time lapse. Astronomers call its rhythm the cadence, which just means how often it revisits the same patches of space. Fast cadence is like checking your doorstep every few minutes. Instead of once a day, you simply miss less. On the ground, that gives us eyes wide and deep. In space, an infrared scout will add something the ground can't. It sees heat. Infrared light is just warmth you can image. So a dark rock that looks charcoal black to a regular camera can glow in infrared like a coal in a campfire. Even better, a space-based infrared telescope doesn't care about clouds, daylight, or the objects sneaking in from the direction of the sun. That's the blind spot that has surprised us before. Finding is step 1. Understanding is step 2. A moving speck needs a personality. Size, spin, what it's made of, how it holds together. That's where rapid characterization comes in small, quick spacecraft sprinting out for a close look. Think of them as first responders with cameras and sniffers. They don't land. They blitz past to measure composition, map surface texture, and watch how sunlight and heat make the object squirm. Those details matter because a rubble pile, a loose heap of rock and dust, responds very differently to a push than a solid boulder. As one mission designer likes to say, you don't kick a sandcastle the way you kick a soccer ball. The third verb is decide. Early. The math of deflection is simple enough to fit on a napkin. Tiny nudges, given years in advance, turn into huge misses later. The real trick is cultural, not mathematical agreeing to move when the risk is only very likely, not certain. Waiting for certainty eats the calendar. A planetary defense lead once told me, early is everything, late is drama. So we practice deciding under a clock. Agencies run tabletop exercises, which are just war games for rocks. They simulate the whole cascade discovery, updates, press briefings, mission green lights, and expose the clogs before a real clock is ticking. Acting has options, and we're finally past the guesswork phase. In 2022, a refrigerator-sized spacecraft slammed into a small asteroid moon and shaved minutes off its orbit. That wasn't a movie stunt. It was the first hard proof that a purpose-built shove works. Better still, follow-up observations showed a bonus you can't see in equations. Debris blasted off the surface acted like a rocket exhaust, magnifying the push. When a European probe arrives to survey the impact crater in detail, we'll replace more "we think" with "we know." One engineer put it in plainer terms. We threw a pebble, and the billiard ball moved. Next time we'll bring a better cue. There are gentler tools, too. A gravity tractor is the slow cooker of deflection. Park a heavy spacecraft near the object and just hover. Gravity does the tugging, millimeter by millimeter, for months or years. The control is exquisite, no smashing, no spraying debris, but it demands lead time and patience. And in the bottom drawer, locked by treaties and trust, lives the nuclear standoff option, not to blast something to bits, but to vaporize a thin skin of material and ride the recoil. Everyone in the field treats that drawer like a fire axe behind glass. You hope to never touch it, but you also make sure it's real, inspected, and governed by rules you wrote together before adrenaline makes bad policy. You can't build this as a handful of heroic saves. It has to be a system that runs on boring days. That means steady money for surveys, not just spurts after scary headlines. It means pre-approved playbooks that release funds the way disaster relief does, automatically when objective triggers fire, not after months of speeches. It means shared sensors, so the Global South isn't only a risk corridor on our maps, but a full partner with telescopes, data links, and trained teams. A researcher from Nairobi said it best. Don't just tell us where the rock is. Give us a seat, a scope, and a say. Public trust is the invisible hardware. Rumor outruns rockets. The communication that works is simple and layered. What we saw, what it means, what happens next. No hedging about uncertainty explain it. No melodrama people can smell that. and rehearse the microphones. In one exercise, teams nailed the spacecraft timelines and then stumbled through the first press Q&A. That was the lesson. As a veteran communicator told me afterward, if you wait to build trust until you need it, you've waited too long. None of this replaces civil defense. It complements it. Even with perfect surveys, there will be surprises, a late fragment, an airburst over water, a dust-rich impact that cools a harvest. Prepared cities withstand the blast better. Prepared grids ride out shocks. Prepared food systems, greenhouses, seed banks, controlled environment farms carry us through a dim season if one comes. The same playbook that helps with volcanic winters and grid-down ice storms helps here. Planetary defense isn't a tower. It's a web, and many of the threads are things we already know how to strengthen. Will all this cost money? Yes, more than we're used to spending on something that might not be needed this decade. But what we buy is time and options. We also buy spin-offs we'll use anyway: better propulsion, sharper navigation, faster data processing, international playbooks for other global shocks. There's a reason people in this field call surveys cosmic weather. You don't build weather radar because you enjoy storms. You build it because you like choosing when to carry an umbrella. There's a quieter dividend too. When we plan as a species to handle a shared, external threat, we get practice that spills over into other hard problems. Agreements about verification, data sharing, and who decides under a clock don't only apply to rocks. They're muscles. You strengthen them, and they help you lift other weights. And yes, there's wonder in it. The same network that keeps watch for hazards also catches the glorious stuff: newborn supernovas, icy visitors with cathedral tales, subtle wobbles of distant worlds. Planetary defense is not a wall that blocks out the universe. It's a window that makes us better at seeing it. That's an important piece of the story to keep in the frame. We're not trying to make space less mysterious. We're trying to make our future less dependent on luck. So if you strip away the acronyms and the acronyms behind those acronyms, what remains is simple. We're building a habit. Watch, understand, decide early, act carefully, tell the truth. We are the first generation that can do this at all. The dinosaurs had a bad day and no options. We have options. The question is whether we'll keep investing in them when the sky is quiet and the budget is loud. A mission planner once shrugged and said, "Rocks don't care if we're distracted. They only care about physics." He meant it as a warning. I also hear it as a kind of permission. Pay attention, build the tools, and let the physics work for us for a change. If 3I ATLAS ever comes in on the wrong line, the difference between a headline and a history bender will be everything we built beforehand. The surveys that spotted it, the small probes that sized it up, the teams that practiced the call, the trust that made a tough choice possible. That's the future where the sky is watched. It's quieter than a blockbuster, but it's the ending worth writing. Let's rehearse a day we're all trying to keep imaginary. It begins with a wobble in the numbers, the sort of small but insistent nudge that makes orbital folks sit up a little straighter. Overnight, the sky surveys send fresh positions to the clearinghouse that keeps score of everything that moves. The automated fit looks fine at first another interstellar passerby, fast and weird, like they always are, but then the uncertainty ellipse, that fuzzy halo of "we're not exactly sure where it'll be later," takes a shape no one likes. It brushes the thin ribbon of space Earth will occupy in a few months. Nothing dramatic yet. Just a faint line drawn across our calendar. What happens next is procedural by design. Independent telescopes ping the same dot from different longitudes, because facts love company. The new measurements shrink the fuzz. The risk number inches up a notch, not because doom is certain, but because we've moved from "that's interesting" to "okay, eyes up." A senior dynamicist summarizes it the way they always do: low probability, high consequence. That phrase is half lullaby, half fire alarm. Within hours, the usual acronyms are on a video call. The people who name storms translate telemetry, answer phones at 3 a.m., and ask ugly questions about uncertainty gather around the same digital table. One of them, who has done this a dozen times, says the quiet part out loud. Let's kill ambiguity before it kills time. The public won't hear anything dramatic yet. They'll get a calm bulletin. Object found, measurements ongoing, next update in 48 hours. No breathless graphics, no shouting. Behind the curtain, though, the triage begins. There are only 3 verbs in this game: watch, understand, act, and they must happen in that order, even when your pulse says otherwise. We watch harder, booking every spare minute on big mirrors. We understand faster, sending a small, quick probe on the first available ride to rush the passerby. Characterization, a dry word for a lively task, means we figure out if this thing is a fragile snowball, a lumpy rock, a loose pile of gravel, or something in between. The probe's instruments are humble but ruthless. A camera sharp enough to catch surface texture, a spectrometer that can read the chemical fingerprints in reflected light, a radio link that times tiny tugs to estimate mass. If you've ever tapped a melon at the market, listening for the sound that tells you what's inside, you already get the idea. While that scout streaks outward, planners sketch branches. One branch assumes we've got years. That leads to gentle options park a heavy gravity tug nearby and let mutual attraction do millimeters per second of slow magic. Another branch assumes we don't. That route points to kinetic impactors, the battering ram spacecraft that shove by striking hard and clean. The difference between those branches isn't ideology. It's clock time. As one mission designer likes to say, we don't pick the tool. The timeline picks the tool. Here's where facts, hypotheses, and speculation raid together. Fact: we have already nudged a small asteroid moon and measured the change. Hypothesis: a scaled-up version, flown as a campaign of 2 or 3 impactors aimed at different spots and angles, can deliver a bigger, cleaner push to a larger target. Speculation: the bonus plume of debris could amplify the shove more than our models predict if the surface is dustier than we think. Each of those braids comes with its own season of doubt. That's why the Scout is so important. It tells us which universe we're living in, sandcastle or bowling ball, and that choice determines how we steer. There's a second set of decisions happening in parallel, and they're less photogenic, but just as decisive. Who speaks when the odds change? Who owns the alarm bell? The best answer is the boring one. The same people on the same schedule with the same plain words. This is not a secret-keeping exercise, a veteran communicator reminds the room. It's a vocabulary exercise. Uncertainty is explained with metaphors that land. A favorite is darts. Early on, you can say the dartboard is still big and your aim is improving. Updates shrink the board until the bullseye is either nowhere near us or uncomfortably close. Another is the highway. We're not on a collision path. We're on a busy interchange with lots of exit ramps, and our job is to take one early, not swerve late. People get that. They live that every day. If the numbers keep tilting the wrong way, the call gets harder and the schedule gets tighter. You want to decide before the odds are 100%, because by then the easy fixes are gone. A planetary defense lead once put it like this: certainty is a luxury item. We pay for it with time we don't have. So you build the mission while the odds are still in motion. You also pre-bake the permissions you'll need, because nothing is slower than writing rules after you need them. Launch providers clear slots. Tracking networks reserve bandwidth. International partners agree who leads which piece. It's not just rockets. It's choreography. At some point, you set the stack on the pad. The first craft is a Pathfinder fast, modest, aimed to paint a better targeting grid and test the way debris sprays. The second and third are the movers. They carry no explosives, only speed and a guidance system that wants the smallest possible bullseye on a moving, tumbling target. Hit the center of mass, not the center of camera, an engineer jokes, meaning the math outranks the pretty picture. When they hit, the object hiccups. Not much, a whisper. But over months, that whisper grows into a missed distance, measured in planet widths instead of wishful thinking. Best case, the trajectory bowstrings just enough that Earth and visitor part like strangers on a sidewalk. We don't pretend that plan is tidy. There are ugly branches on the tree. Maybe the surface is tougher, the plume weaker, the push smaller. Maybe the first hit unzips the object into two big pieces instead of one, and now you're playing shepherd with twins. Maybe the shove works perfectly, but it trades a bullseye for a near miss. Good for us, bad for satellites or future explorers. Those are not movie twists. They're real rooms in the house, and you walk through them at the whiteboard long before you ever light an engine. You also keep a locked drawer of last-ditch options no one likes to discuss, the ones that require treaties to breathe and new kinds of trust to function. If we ever open that drawer, it should be because we wrote the rules in peacetime and decided together what only if really means. Meanwhile, back on the ground, life goes on. Kids go to school, buses run, pizzas get delivered, but with a new layer of rehearsal. City planners dust off plans they made for storms and earthquakes and adapt them to shock waves and power flickers. Farmers talk with scientists about light levels and cold-hardy crops, not because disaster is certain, but because resilience pays dividends no matter what. In coastal towns, siren systems go through extra tests. In hospitals, diesel tanks get topped off and backup supply lines get mapped. The same things that help with wildfires and winter storms help here, a resilience officer says into a mic. It's not drama, it's muscle memory. If the mission works, and statistically, early and well-planned makes works. A favorite, there's no fireworks. The visitor becomes a dim speck again, and then not even that. In a few months, it slips back into the dark between stars, a ghost with a slightly different story than it brought in. The headlines last a day. The footage of launches ages well on YouTube. A late-night host makes a joke about the most expensive game of billiards in history. And at a quiet table in a quiet room, someone refills the coffee and starts an after-action report that begins with the single most important sentence in this business. What did we learn that shortens the next reaction by a week? But if the miss distance isn't what we hoped, if the math says we will eat some of the dust no matter how well we shove, the mood shifts without tilting into panic. Now the emphasis is on civil defense and rationing and sunlight you can grow under. We prepare for the worst and then meet the day we actually get, an emergency manager says, and that line becomes a little mantra. People take comfort in jobs to do. They check on neighbors. They join lines that are orderly because trust was built before it was asked to carry weight. It's not romantic, but it's the way communities survive everything from ice storms to rugby finals. The playbook is surprisingly familiar, and that's the point. There's one last truth worth saying out loud before we fold up this rehearsal. This is not a hero story about one nation, one agency, one brilliant scientist who solves it all with a chalkboard. It's a network story. The win condition is boring competence shared widely surveys that keep scanning on dull nights. Software that catches the weird dot before breakfast. Launch teams that can thread a needle on short notice. Diplomats who've already agreed who says yes. If we ever face the wrong line from something like 3I ATLAS, the thing that saves us won't be a last-minute miracle. It'll be the years we spent choosing to be ready when no one was watching. If you're still awake, let's try something a little different. Close your eyes and picture a map of the world without borders. Just coastlines and mountain spines and the faint glow of cities stitched across the dark. Now float above it and sprinkle in the people most likely to notice trouble first, the night shift observers, clicking through images at 2A. The amateur with a backyard rig that squeaks when it's loose. The student who just learned that uncertainty ellipse isn't a metaphor. It's the way the future looks until you measure it again. These are not action movie roles. They are patient ones. They sit between the sky and our stories and try over and over to get the two to match. When a visitor like 3i Atlas shows up, that matching game turns into a collective act. The pros publish their measurements. The hobbyists confirm. The computers extrapolate. And the rest of us do what humans always do. We tell ourselves a tale big enough to fit the feelings. Sometimes the tale leans heroic. Sometimes it leans haunted. Either way, the plot lives on two rails at once. The one made of numbers and the one made of meaning. Keeping those rails parallel is the quiet art of planetary defense communication. Facts first, color second. As one outreach lead puts it, give the why before the wow. There's a rhythm to that craft you start to recognize. Newsroom calls the observatory. Observatory calls the coordination center. The coordination center calls the people who choose words with tweezers. The first message is the one that matters most, and it's intentionally dull. What was seen, who saw it, how sure they are, when we'll know more. No adjectives, no music. A meteorologist once told me the rule of severe weather. Name the hazard, name the timing, name what to do. The sky doesn't care whether you're calm or panicked. Only the plan does. The same applies here. If a risk estimate grows, the wording tightens. If it shrinks, the update celebrates by being short. Of course, the internet is an oxygen tank for what-ifs. If there's a vacuum of detail, rumor rushes in. That's why scientists now treat social feeds like crowded town squares. They post the graphs and the plain language translations side by side. They link to the live trackers that anyone can read, even if they only understand the colors. They pin the part most people actually need. No, this is not a doomsday. Yes, we'll tell you if that changes. And they keep pinning it, no matter how many times the conversation veers toward drama. As Carl Sagan used to remind us, extraordinary claims require extraordinary evidence. And until you have the latter, you owe the former exactly zero oxygen. If you want to see the opposite of drama, watch a fit and update session in a small telescope room at 3 in the morning. You'll see a pot of coffee that could dissolve a spoon, a whiteboard with dates circled like birthdays, and a screen with the future as a cloud that tightens as the night gets older. Every new observation nudges that cloud. Sometimes it nudges toward us. More often it slides away, gently, like a door being closed in slow motion. That is the most common ending in this line of work. Nothing happens, and the victory is invisible. Let's separate our ingredients the way we promised to all along. Fact: interstellar visitors are rare, fast, and usually harmless. Hypothesis: their speeds make even small ones more energetic than our instincts expect, which is why we practice deflection on playground targets before we ever face a varsity game. Speculation: somewhere out there, a larger visitor could arrive on an inconvenient line. That last sentence is the one that attracts capital letters and exclamation marks. But it's also the one made safer by routine. The more often we rehearse the dull part-sharing data, shrinking uncertainties, speaking clearly, the less space there is for panic to write the script. There's another quiet actor in this story that deserves a bow: the humble backyard telescope, and by extension, the people who use it. Amateur sounds like hobbyist. In practice, it often means first responder. Many of the follow-up dots that harden in orbit come from folks whose observatories are sheds wired with love and spare parts. They do not need permission to care. They just need clear skies and a community to plug into. When things get interesting, those networks hum mailing lists, discords, ancient forums with fonts from 2003 all, buzzing with the same choreography. Here's tonight's ephemeris. Here are the exposure times that work. Here's what to avoid. It's the world's most charming volunteer fire brigade. If you like your comfort a little more official, you'll find it in checklists. Agencies have them for everything now. Early detection notification, public brief template, observing window triage, rapid rendezvous kit. The kits are real design docs and parts lists that can turn spare mass on a commercial rocket into a scout probe with a camera, a radio, and a plan. That's not a wish list, it's a shelf. The difference between those two is measured in months saved when the calendar suddenly matters. We don't build hope. One mission architect told me with a shrug. We build hardware. Even a perfect plan has to pass through culture on its way to action. That's where stories, faiths, and fears meet policy, and where you learn that science alone can't carry the load of meaning. Some people will hear low probability and sleep fine. Others will hear non-zero and think about their kids. It helps to name that difference and be kind to it. It also helps to keep the scale honest. Lightning, earthquakes, storms, most of us share a mental map for those. We know what a watch is, what a warning is, what a false alarm feels like, and why it's not failure. This is the same family of problem, a natural hazard with long odds and big stakes, managed best by steady investment and practiced response, not magical thinking. If you want a window into how far we've come, set today next to 1910, when Halley's Comet last scared people for all the wrong reasons. Newspapers sold masks for poisonous comet gas. Novelists wrote about cometary pestilence. Charms were hawked. The night passed, the world turned, and a lot of people learned the hard way that fear is the most expensive telescope you can buy. It sees threats that aren't there, and it misses the ones you can actually do something about. This time around, when a bright visitor glides by and the sky fills with camera phones, the most popular post is likely to be someone's backyard photo, annotated with the correct names for the tails. All this practice doesn't just save us from unlikely disasters, it improves ordinary life. Better sky surveys catch more asteroids and more supernovas and more weird flares that teach us how stars live and die. Better propulsion built for a nudge mission makes deep space exploration cheaper. Better crisis messaging honed for a once-in-a-century risk spills over into wildfire seasons and heat waves and blackouts, where it pays off in very human ways. The bill for readiness is never wasted. It keeps the lights on in places that have nothing to do with comets. There's a simple, stubborn humility at the heart of this, and it's worth keeping close. You can know almost everything, measurements, models, analogies, and still have to live with a sliver of unknown. That sliver is not a failure of science. It's the reason science exists. We pull it thinner and thinner with each new observation, each small, clever mission, each sunrise that finds the telescopes where they're supposed to be, open, patient, impartial. And when a surprise arrives, and they do, in the skies and life, we meet it with the same tools that make kitchens work and neighborhoods safe. Habit, cooperation, and a shared understanding of which rumors to ignore. So if you find yourself lying awake tonight, listening to your own private what-ifs, try trading one of them for this quieter picture. Somewhere, a camera is taking a 30-second exposure of a field of stars, so ordinary it hurts. Somewhere, a grad student is turning that smudge into a number, and that number into a point on a plot, and that point into a little bit less uncertainty for all of us. Somewhere, a mission lead has a go bag of designs ready to pull off the shelf, and a phone that will wake them if the shelf needs emptying. None of those scenes is cinematic. All of them are why the future so often arrives undramatically, and why sleep is usually the right response to a clear night. If one day, it isn't if the odds ever stack in a way that asks us to do more than measure and admire, the same people will still be there. And so will we, less as bystanders than as participants in a plan we wrote together in peacetime. We'll keep the rails parallel. Numbers and meaning, facts and feelings. The watch, understand, act cadence that lets realism and hope share. The same sentence without stepping on each other's toes. That's the real comfort here, bigger than any single visitor. Not that nothing bad can happen, but that we've gotten very good at doing the next right thing when the sky gives us homework. Tonight our story tightens. Picture the control room lights dimmed to protect night vision, the soft whir of air conditioning, the muted clack of keyboards. On the main screen, a pale rainbow of probability threads the solar system like yarn stretched between thumbtacks. That ribbon has a name risk corridor, and for the first time in our tale, a hair-thin strand runs across Earth like fishing line. Not a bullseye, not a guarantee. Just the kind of maybe that makes professionals sit up straighter. Facts first. A risk corridor is the set of possible future paths an object could take given everything we know and don't know. Hypothesis next. If the line still touches us after another week of measurements, the odds are real enough to pull hardware off the shelf. Speculation last. This could be the moment the practice drills stop being practice. The phones start in their polite way. A coordinator pings the amateur networks, those backyard observatories we met earlier asking for time, on targets just after moonset. A radio astronomer messages the team in Chile. Can you grab the trailing residual? Our model wants a longer arc. You can almost hear the orbit narrowing as data slides in, like a camera lens racking into focus. There's a rhythm to this, and it's not panic. It's craft. One veteran puts it like a mantra. Measure twice, announce once. The first public update is dry on purpose. Where it is. How bright. What's next? If there's a number for risk, it's spelled out in words and context. Small for now, smaller with more observations. Expect another update tomorrow. No sirens, no adjectives that can't be defended. Still, the ribbon doesn't let go. Night after night, the error bars shrink like a tightening belt, and the thin strand that grazed Earth refuses to lift entirely. The modelers swap fit here, just meaning a best guess path argue gently about dust pressure, rotation state, thermal lag. We promised no formulas, so here's the picture. Imagine you're guessing where a paper airplane will land after someone throws it in a breezy room. You watch how it glides, you learn its wobble, you write a map of places it might touch down. Early on, the landing zone covers half the carpet. Later, it's a bean-shaped patch near the couch. That bean is our corridor. Earth sits partly in it. This is where the second orchestra takes its cue. The mission folks. The nudge, planned polite name for a kinetic impactor moves from binder to checklists. A nudge is exactly what it sounds like. A fast, sturdy spacecraft, ramming the object to shift its path by a whisper of speed, early enough that the mist grows into thousands of kilometers by the time it matters. The beauty is in the timing. A millimeter per second change today can mean city-width differences months from now. No drama at the moment of contact. The drama belongs to the math. If the timeline is tight, a backup plan, the gravity tractor, the slower cousin that just parks nearby and pulls gets dusted off anyway, because options are grown, not wished. In the same breath, the ethicists and diplomats take their seats. It sounds grand, but it boils down to a simple knot. If a nudge shifts the corridor, where does the thread move to? Could a small push relocate a hypothetical impact from ocean to land, or from one country's risk to another's? There are rules now about how to ask that question out loud. You don't parade maps with colored bullseyes. You don't create villains. You talk in ranges and confidence and what-if branches, because that's what the sky is offering you, branches. One negotiator's line always lands softly. We share the hazard, we share the remedy. Back in the control room, a new voice joins the chorus, the microwave eyes. An instrument that sees heat rather than light catches a faint warm blur where sunlight should make the visitor glow. That's good. Not because warm means friendly, but because warm is a clue. Comet nuclei are like thermoses. They hold heat, leak it strangely, where mufflers of dust that change how they respond to sunlight. Map that leak, and you learn how hard you'll have to tap to change the path. Fact: a fluffy snowball absorbs a shove differently than a welded rock. Hypothesis: this one looks more snowball than steel. Speculation: a well-aimed nudge might deliver more change than the raw numbers suggest, thanks to the plume that kicks backward like exhaust. Now the story telescopes to living rooms. You, me, anyone who ever looked up and felt small. The headlines find us. Some are careful, some less so. Non-zero becomes possible, becomes incoming in a game of telephone no one asked to play. This is when the communication teams do their most important work, which is strangely boring. They repeat the facts without apology. They remind people what 1 in X actually means. They keep the tools public, the live trackers, the nightly pressers, the Q and As, where a scientist starts every answer with, "Here's what we know, and here's what we don't." If fear is a vacuum, clarity is air. And still the corridor skims us. The models converge toward a week that now has a circled date, not Impact Day Decision Day. That's when the launch window opens for the nudge craft. Window just means the span of hours where, if you light the engines, you'll actually meet the target instead of waving at it from across space. Someone makes the best analogy I've ever heard. Hitting an interstellar object is like trying to merge onto a highway and bump a passing motorcycle with a pool cue from a moving pickup, except your pickup is also on skates. That's why we train. That's why the test mission a few years back mattered so much. We know the cue doesn't splinter. We know the nudge adds up. A few decisions happen fast because they were rehearsed. The mission gets greenlit at a lower threshold than a month ago, with a pre-agreed rule. If the odds stay above a line by this date, we launch, and we can always stand down. That's not machismo. That's calendar math. You can always cancel an action, one flight director says, but you can't schedule yesterday. Insurance markets twitch, then breathe. Grain traders glance at climate models and push their chairs back in. School kids ask better questions than anyone in the comments. Do comets have fingerprints? Does space smell like anything? If you nudged it too much, could it hit the moon? The answer order is yes in a way, like metal and cold, and we'll aim to miss everything. Thanks for asking. On the factory floor, something beautiful and unglamorous happens. Shelves empty into crates. The camera that had a different mission now has this one. The guidance computer that was headed for a calm cruise, it's paired with thrusters that can think fast. A commercial launch provider offers a slot. A second provider offers a backup. A third offers a ride for a tiny scout probe that can fly ahead and send back. The last shreds of uncertainty about rotation and texture. You can hear the smile in one engineer's voice, even through the fatigue. We built this to be boringly reliable. I've never loved boring more. The night before the board signs the final go. A thing we don't often talk about happens in rooms like this. People call home. Not because doom is certain, but because pivot points make you take inventory. They say things like, "I'll be late all week," and tell me if the dog won't eat. And then they walk back into the humming light and do more math. The corridor on the big screen is thinner now. Not a ribbon, but a hair. It still grazes us. The window opens in 32 hours. The rocket is fueled. In a colder story, this is where we would engineer tension by cutting to black. But our promise was to respect the way real life climaxes. In increments, with coffee that tastes like pennies, and a dozen small choices that add up to one big steer. Then the universe reminds us why we never get cocky. An observatory at dawn catches the visitor flaring brightening, as a jet of vapor vents from a patch of its surface that has just come into sunlight. That jet is not panic, it's physics. But it shifts the path a whisper. The team reruns the fit. The hairline lifts off Earth by a few thousand kilometers. Not safest, not forever, but enough that today's corridor no longer draws through our living room. The room doesn't cheer. It exhales, then it checks whether the shift holds across fresh data. It does. Do we stand down? Not yet. The checklist says wait for 3 independent confirmations. They arrive over the next 2 nights from telescopes you've never heard of, but would love for how stubbornly they keep watch. The corridor lifts further. The risk drops under the line the board set when everyone still had 5 minutes to eat lunch. The nudge mission moved from go to pad to stay flight ready, not a cancellation. A pause with a heartbeat. You don't throw away a parachute because the sky cleared. You fold it better. Here's what our climax really is then. A collective decision to prefer boring heroism over cinematic. We kept the rails parallel numbers and meaning long enough for nature to nudge herself. We built the hardware anyway, because that's what adulthood in a cosmos like this looks like. We talked straight without selling fear, and fear had fewer places to hide. Fact: the visitor will not hit us. Hypothesis: we'll see it again as it slides past. Pick apart its light for clues about its birthplace. Stack those clues next to the fingerprints of others until a picture of other suns' backyards emerges. Speculation: there will be a next time that does not lift on its own, and the muscle we built here, the checklists, the international phone trees, the habit of not overpromising, will be what matters most. If you want a last image to carry into sleep, try this. The risk corridor on the main screen fades from hot colors to cool. The room dims a notch. Someone tapes a note above a desk. Measure twice, announce once. Someone else replaces the dead plant by the window. An engineer writes a date on the whiteboard and circles it, not as a threat this time, but as a reminder to spin the nudge craft's wheels every few weeks so they don't forget what their job feels like. Outside, the sky is just the sky again. It was always that indifferent, immense, occasionally generous. We got to a good outcome, not because the universe owed us one, but because we built the habit of earning it. If you've made it this far with us eyes a little heavy, curiosity still awake, then you already know the shape of the answer. The sky isn't out to get us, and it isn't out to save us. It's just out there, full of travelers that don't know our names. The fear we started with: what if a fast stranger from another star, lined up with our world, turns out to be less about doom and more about timing, teamwork, and honesty? Timing, because a whisper of speed changed months early, is better than a shout a week late. Teamwork, because no single observatory, agency, or country can watch every patch of sky or build every piece of hardware. Honesty, because numbers are not prophecies. And the most adult thing we can do is say, here's what we know, here's what we don't, and here's what we're doing next. Let's land this gently, keeping our promise to separate what's solid from what's wispy. Fact: interstellar objects exist, and they sometimes pass through our neighborhood faster than anything we've launched. We have seen them. We will see more. Fact: energy from a collision depends overwhelmingly on speed, which is why small, fast visitors matter in a way that surprises people. Fact: we now have proof that a carefully aimed spacecraft can nudge a small world in a measurable way. None of that is science fiction. It's Tuesday for the folks who spend their nights measuring smudges against the stars. Hypothesis: as our surveys get better and our eyes move into space where weather and daylight can't bother them, we'll spot dangerous visitors earlier and more often. That doesn't guarantee perfect safety, but it tilts the game toward the side with checklists and coffee. Hypothesis: the more we practice clear public communication saying low probability, without either sugarcoating or sensationalism, the steadier the world will be when a story like this leaves the science page and lands on everyone's phone. Speculation: one day an object will not lift off the risk corridor on its own. The flare won't nudge it away. The line will hold across Earth, and the decision will land on real desks with a clock running. And when that happens, the right answer will be found not in heroics, but in all the boring excellence we've been rehearsing. Early detection, graceful international phone trees, hardware that was kept on the shelf ready to fly, agreements written in calm hours that we can follow in noisy ones. The movie version loves the last-second save. The real win is never being on the last second in the first place. Along the way, we picked up a few useful translations, the kind you can keep in your back pocket. Risk corridor is just the map of where an object might go as we peel away uncertainty. Nudge is a polite word for a kinetic impactor of fast, sturdy spacecraft designed to trade its own life for a millimeter per second change that grows into safety. A window isn't a view. It's the slice of time where a launch can actually intersect with a target in the geometry of space. And non-zero doesn't mean incoming. It means the game is at the stage where more measurements matter. We also got to meet the people who live at this intersection of wonder and paperwork. The amateur astronomers who turn backyard domes into a global net, catching faint motion between clouds. The catalog wranglers who turn thousands of blips into one moving thing with a personality. Rotation, texture, heat. The mission planners who can look at a calendar and feel the physics under it, the way a carpenter can feel when a joint is true. The diplomats who remind everyone to share both hazard and remedy, because gravity doesn't honor borders, and neither should survival. And the kids who ask the perfect, disarming questions that keep the adults honest. If anything in this journey surprised you, maybe it was how unglamorous the climax felt, and how right that is. No trumpet blast, no countdown over a trembling planet. Just a series of small, careful calls that add up to one big steer. A rocket fueled and ready, then left politely waiting because nature handled it herself this time. A team that kept its promise to act if needed, and to stand down if not. A public briefed in plain language, so fear had fewer dark corners to nest in. It turns out the opposite of panic isn't apathy. It's competence. So what would really happen if one of these fast strangers lined up on us? You know the answer no. Not in the specifics, those depend on the size, the angle, the target, the clock, but in the posture. We would measure until the uncertainty behaved. We would map the corridor and look each other in the eye about what the numbers mean. We would open the launch window as soon as the rulebook says, and fold the parachute carefully if we don't need to jump. We would pull power and food into the places that might see the worst, even as we work to make sure they never do. We would protect the quiet, clever work that is easy to cut when fear is low and desperately needed when fear rises. And if it came to that, we would nudge early, small, boring, beautiful. There's comfort in knowing the sky is watched. Not watched by an all-seeing anything, but by people sleep-deprived, underfunded, stubborn in all the right ways, who keep showing up. It's the same comfort as a lighthouse, a modest being, sweeping. You can sleep because someone else is awake. You can also help them by caring enough to keep the lights paid for and the glass clean. As we close, here's a thought to carry into dreams. Our species is the first on this planet to even know the question exists, much less to build a realistic answer. Dinosaurs had no surveys, no windows, no phone trees. We do. That doesn't make us invincible. It does make us responsible. For the forests that would burn if we misjudge. For the oceans that would heave if we're late. For the children who will inherit either our apathy or our preparation. We can't vote on gravity, but we can vote on what we do about it. If tonight's calm has put you at ease, good. If it's also put a small, persistent itch in your head, an itch to keep learning, to keep supporting the quiet work that keeps loud disasters small even better. We'll keep telling these stories, walking the line between wonder and worry, because that's the real service a midnight documentary can perform. Turn fear into questions, and questions into plans. If you want to help this little lighthouse shine, you know the drill. Subscribe so you don't miss the next patrol. Drop us a comment with one very specific call. If the odds stayed at 1 in 500 with a week to spare, would you greenlight the nudge or wait for more data? Tell us why. And while you're there, suggest our next mission. Do we ride along with a kinetic impactor from assembly to impact? Do we follow a gravity tractor slow dancing with a rock for a decade? Or do we aim for something wilder? What it would take to land, sample, and return a handful of material from an interstellar visitor before it slips back to the dark. Wherever we go next, we'll keep the same compass. Facts first, hypotheses with their seatbelts on, speculation clearly labeled, jokes close at hand. The universe will keep sending strangers. We'll keep meeting them at the door with the right mix of hospitality and boundaries. And if one ever comes too close for comfort, we'll already have both the language and the tools to write a better ending. The sky is vast. Our era is brief. But sometimes brief is enough to matter.